students present here and teachers, those who have not registered, I request you to please register in the registration counter and come back. ಯಾರು ರಿಜಿಸ್ಟ್ರೇಷನ್ ಮಾಡಿಲ್ಲ ಇಲ್ಲಿರೋರು ದಯವಿಟ್ಟು ರಿಜಿಸ್ಟ್ರೇಷನ್ ಮುಗಿಸ್ಕೊಂಡು ಬರಬೇಕು. program will start in another 5 minutes. I request everyone to settle down. Good morning to one and all. We are gathered here today to celebrate 50 years of the launch of India's first satellite, Aryabhatta. Aryabhatta was launched on this day, April 19th, in the year 1975. The launch of this satellite marked the beginning of India's space age and laid a firm foundation to India's satellite program. On this joyous occasion, I welcome the Honorable Chief Guest, other dignitaries, invitees, and the audience to today's program. Before we begin the program, I request everyone to please raise for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
I now request the Honorable Chief Guest and the dignitaries to kindly occupy their seats on the dais. For the invocation, I call upon Ms. Lakshmi to invoke the blessings of the Almighty through the invocation song. ಗಜಮುಖ ವಂದಿಸುವೆ ಕರುಣದಿ ಕಾಯೋ ಗಜಮುಖ ವಂದಿಸುವೆ ಕರುಣದಿ ಕಾಯೋ ಗಜಮುಖ ವಂದಿಪೆ ಗಜಗೌರಿಯ ಪುತ್ರ ಗಜಮುಖ ವಂದಿಪೆ ಗಜಗೌರಿಯ ಪುತ್ರ ಅಜನ ಪೀತನ ಮೊಮ್ಮಗನ ಮೋಹದ ಬಾಲ ಅಜನ ಪೀತನ ಮೊಮ್ಮಗನ ಮೋಹದ ಬಾಲ ಗಜಮುಖ ವಂದಿಸುವೆ ಕರುಣದಿ ಕಾಯೋ ನೀಲಕಂಠನ ಸೂತ ಬಾಲಗಣೇಶನೇ ಬಾರಿ ಬಾರಿ ಗುರು ಸ್ಮರಣೆ ಮಾಡುವೆನಯ್ಯ ನೀಲಕಂಠನ ಸೂತ ಬಾಲಗಣೇಶನೇ ಬಾರಿ ಬಾರಿ ಗುರುನ ಸ್ಮರಣೆ ಮಾಡುವೆನಯ್ಯ ಪರ್ವತನ ಪುತ್ರಿ ಪಾರ್ವತಿಯ ಕುಮಾರ ಗರುವಿಯ ಚಂದ್ರಗೆ ಸ್ಥಿರ ಶಾಪ ಕೊಟ್ಟನೆ ಗಜಮುಖ ವಂದಿಸುವೆ ಕರುಣದಿ ಕಾಯೋ ಹರಿಹರರು ನಿನ್ನ ಚರಣ ಪೂಜೆಯ ಮಾಡಿ ದುರುಳ ಕಂಟಕರನು ತರಿದು ಬಿಸುಟಿಹರಯ್ಯ ಹರಿಹರರು ನಿನ್ನ ಚರಣ ಪೂಜೆಯ ಮಾಡಿ ದುರುಳ ಕಂಟಕರನು ಸುಟಿಹರಯ್ಯ ವಾರಿ ಜನಾಭ ಶ್ರೀ ಹಯವದನನ ಪಾದ ಸೇರುವ ಮಾರ್ಗದ ದಾರಿಯ ತೋರಿಸೋ ಗಜಮುಖ ವಂದಿಸುವೆ ಕರುಣದಿ ಕಾಯೋ ಗಜಮುಖ ವಂದಿಪೆ ಗಜಗೌರಿಯ ಪುತ್ರ ಗಜಮುಖ ವಂದಿಪೆ ಗಜಗೌರಿಯ ಪುತ್ರ ಅಜನ ಪೀತನ ಮೊಮ್ಮಗನ ಮೋಹದ ಬಾಲ ಅಜನ ಪೀತನ ಮೊಮ್ಮಗನ ಮೋಹದ ಬಾಲ ಗಜಮುಖ ವಂದಿಸುವೆ ಕರುಣದಿ ಕಾಯೋ.
Thank you, Ms. Lakshmi, for such a melodious invocation. Now I request the dignitaries to light the lamp symbolizing the formal inauguration of this function. I also request them to pay floral tributes to Professor U R Rao, the architect of Aryabhatta and the father of Indian satellite program.
शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तु ते दीपज्योतिर्नमोऽस्तु ते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः. ज्योतिर्जनार्दनः दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपो हरतु मे पापम् सन्ध्यादीपनमोऽस्तु ते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः.
Now, I call upon Dr. Gurup Prasad, Director, Jawaharlal Nehru Planetarium, to formally welcome the gathering.
Respected Chief Guest of today, Professor Subramanyam Madam, Director, Indian Institute of Astrophysics, and Shri A.S. Kiran Kumar Sir, Member Space Commission and Chairman Base Council, Jawaharlal Nehru Planetarium, Dr. T.K. Alex Sir, Vice Chairman, Base Council and former Director of U R Rao Satellite Center, and Shri M. Shankaran, Director, U R Rao Satellite Center, Base Governing Council members, senior scientists from ISRO, state and central government organizations, invitees, friends from the media, ladies and gentlemen, and most importantly, my dear students. What a privilege it is for me. And let me say first, good morning to all of you. Indeed, I am privileged to welcome you all to this function celebrating the Golden Jubilee of the launch of Aryabhatta, the first Indian artificial Earth satellite. It is important to note that this first satellite was built in India under the mercurial leadership of Professor Ramachandra Rao, known to millions reverently as Professor U R Rao. It is not an exaggeration to say that the experience gained during the building of Aryabhatta, as well as its management in orbit, put a solid foundation to the Indian satellite program, which has many conspicuous achievements to its credit. Besides, robotic spacecraft like Chandrayaan, Mangalyaan and Aditya, which evolved from satellites, have revealed the technological prowess of the country to the world at large. Satellites have now become an integral part of India's economic infrastructure and contribute significantly to the comprehensive security of the country. Thus, it is very appropriate to nostalgically look back to the days of India's first satellite and to reminisce about the evolution of the Indian satellite program. That's what is exactly being done here today at Jawaharlal Nehru Planetarium in this function, organized jointly by ISRO's U R Rao Satellite Center and JNP. For this event today, we have a galaxy of scientists of repute on the dais. At first, Professor Subramanyam, Director, Indian Institute of Astrophysics, is here with us to kindly grace the occasion as the chief guest. Of course, all of you know this is a Indian Institute of Astrophysics is a premier scientific institution of India, which provided payloads to AstroSat as well as Aditya L1 spacecraft. So on behalf of URSC and JNP, as well as on my own behalf, I extend a warm welcome to Madam. Now I request Ms. Rajeshwari to present Madam Asapli. Please. Welcome, Madam, once again. And we have amongst us Shri A.S. Kiran Kumar sir, who is the chairman of the Governing Council of BASE that administers Jawaharlal Nehru Planetarium, and he has kindly consented to preside over this event. Shri Kiran Kumar sir was earlier chairman of ISRO, and now he is a member of the Space Commission of India, and what events, momentous events occurred during his chairmanship, all of us know, including the launch of 104 satellites in a single launch. And I heartily welcome you, sir, on this occasion, please. Okay, I request Ms. Pushpa to present Sir a sapling, please. Dr. T.K. Alex is the Vice Chairman of the Governing Council of BASE JNP. He is also amongst us to speak to us on the legendary Professor U R Rao, the architect of Aryabhatta and the father of the satellite program, Indian satellite program. Dr. Alex worked with Professor Rao on Aryabhatta project, and I'm sure Sir is going to share some fond memories of Professor Rao with us. Welcome to you, sir. I heartily welcome you. I request Ms. Lakshmi to present Sir a sapling. Another person of repute on this dais is Shri M. Shankaran, current director of U R Rao Satellite Center. For your kind information, U R Rao Satellite Center, or URSC as it is known universally, is the center in which Indian satellites and robotic spacecraft like Chandrayaan take their final shape. Shri Shankaran has been instrumental and very enthusiastic in encouraging and facilitating outreach events like this, which have the ability to inspire millions of students and to instill pride in them. In fact, we have sent some of the material prepared on this occasion for students to science centers across Karnataka as well as major planetaria of the country to enthuse students on India's achievements in space. They will also be doing some programs today, okay, as per our request. And a 3-minute sky dome show, that is whatever is shown in planetariums, let us say, on Aryabhatta and satellite technology evolution in India is being prepared jointly by URSC and JNP, which will be sent to all planetaria in India for use in their dome show program. It will be done shortly. Thanks to Shri Shankaran for facilitating this, and my heartfelt welcome to you, sir, Shri Shankaran. I request Ms. Sharanya to present Shri Shankaran assembly. Amongst us, We also have Dr. K.V. Shri M, Director of ISRO's Laboratory for Electro-Optic Systems, LIAS, and of course, he is the chairman of the Golden Jubilee Celebrations Committee of Aryabhatta launch. I offer my hearty welcome to Dr. Shri M, and I request Ms. Likita to present him a sapling. Please. Besides Shri A. Rajendra, Deputy Director, Mechanical Systems Area of URSC, and alternate chairman, Golden Jubilee Celebrations of Aryabhatta launch is also here. A warm welcome to you, Shri Rajendra. I request Ms. Sujata to present a sapling to Mr. Rajendra. Thank you, sir. It's a matter of immense pleasure that I would like to announce that to all of us today, that Professor Madan Rao, son of legendary Professor U R Rao, has graced the occasion along with his son. So kindly, and he is with us here. My hearty welcome to you, sir. So nice, so nice. Give a big ovation to Professor Madan Rao. Welcome to you, sir. I also welcome invitees, including base governing council members, senior scientists from ISRO, academicians, senior officials of state and central government departments, and teachers. I also welcome media and thank them for their kind response to our request to cover this event prominently. Finally, I welcome the students who have gathered here in large numbers and their teachers with great expectation to participate in this program and to get inspired. Welcome to one and all. Thank you.
Thank you so much, sir. I request Ms. Lakshmi to hand over a sapling to our director also. Thank you, sir. As a part of this special celebration, let us watch a documentary that captures the remarkable journey of Aryabhatta, a tribute to India's pioneering step into space. This documentary is jointly made by U R Rao Satellite Center and LEO's ISRO.
Aryabhatta was a small satellite that brought realization in Indians that we too can dream big. The journey had started much earlier when Dr. Vikram Sarabhai entrusted the task of preparing a thesis on how satellites can be used to Professor U R Rao.
So I wrote a sort of a thesis, took 2 months, and then gave it to him. And he said, I like the thesis, wonderful it is, but one thing I don't like. I said, what is it which you don't like? He said, you haven't said who is going to do it. I said, Vikram, that is your problem, to find somebody who is going to do it. You wanted me to write the thesis, I wrote a thesis for you. And he said, no, you have to accept it.
On the outskirts of Bangalore city, Professor U R Rao was shown the skeleton of a few industrial sheds which were just being built for the new Pina Industrial Estate. Immediately, he booked for the first 4 sheds, each with 5,000 square feet area, to start the Indian Scientific Satellite Project, previously known as the Indo-Soviet Satellite Project. By the end of August 1972, we got the sheds.
We assigned him the task to organize the team. We hired a few buildings at Pina, which is a little village a few miles away from Bangalore, and Professor Rao and his team rapidly converted these into the satellite laboratory.
Aryabhatta is a spin-stabilized 360 kg satellite of nearly 1.5 meter diameter, having a multifaceted oblate spheroid shape with 26 faces made up of body-mounted solar panels generating 50 watts power. Attitude is provided by sun aspect sensors, digital sun sensors and a magnetometer. It's a spin-stabilized satellite. It has a tape recorder for recording 40 minutes of telemetry data and batteries. Cosmos chips are used in the system to meet low satellite power. It has a dual redundant telecommand system, dual redundant telemetry system with common telecommand and telemetry antennas. The work went on in an unbelievable pace. To study the physical characteristics of the satellite in actual conditions in space, a structural model of the satellite and a thermal model were built and tested. A half model was tested and qualified with the dummy last stage of the rocket in USSR. An electrically working model was flown on a helicopter over Sriharikota ground station and over the Bears Lake station near Moscow to test the operation of the entire telemetry, telecommand and communication links. An interferometer system for providing the precise orbit of the satellite was built in Sriharikota. 2 months before the launch, the team suddenly felt the need to have a second telemetry ground station for redundancy, in addition to the main station at Sriharikota. Behind the sheds, 2 lavatories meant for women were cleaned up and quickly converted into a full-fledged ground station.
Zero hour ticks forward. A tense excitement prevails. And off goes Aryabhatta, India's first scientific satellite.
Aryabhatta project continues to be the benchmark.
That was indeed a very inspiring documentary, wasn't it? Now, I request Shri M. Shankaran sir, Director, U R Rao Satellite Center, to deliver the inaugural address.
Thank you. Good morning to all. Respected dignitaries on the dais and of the dais, and my dear children. It gives me great pleasure to be here along with you to celebrate the 50th anniversary of Aryabhatta launch. As already mentioned by Director Planetarium, that it is on this very day And today, Kiran Kumar sir also pointed out, it is also the very day also, that is Saturday. A similar Saturday, 50 years ago, the satellite soared into the sky with the help of a Russian rocket. But that has happened 50 years ago. Does it have any importance today, particularly for young people, children like you, students? It is a reminder that our imagination is the only limit to what we can achieve. To recollect when the Indian space program started in the 60s, very, very low key, upon the initiative of two legendary figures, Professor Vikram Sarabhai and Dr. Homi Bhabha. These are the two people who imagined that in spite of India being in such difficult situations economically, because in the 60s and even early 70s, food shortage was there in India many times. Recurrent food shortage used to be there. And in the middle of 60s, India had a disastrous war against our northern neighbor, and India was getting aid in the form of food grain from foreign countries. Our situation was like that. In that situation, these two gentlemen imagined that in the future, space technology can solve at least some of these problems or help in solving some of these problems. This imagination was what finally got fructified into the Aryabhatta satellite, which was realized in a time frame of about 2.5 years. No time overrun, no cost overrun. Even today we cannot imagine any satellite or any other program for that matter that whether we will be able to do without time and cost overrun. It is a lesson in project management and engineering management, and those who know Professor U R Rao, also people management. That is the importance of this day, even after 50 years, that to remind us that if we are getting focused on our daily problems, our immediate difficulties, and get bogged down by that, we may miss the future. So in spite of our problems today, if we can imagine a future and work towards that diligently, success is ours. That is the outcome, at least according to me, from this Aryabhatta, and this is the message we also wanted to convey to the student community of today, who have the ability to imagine and carry India forward in the future. That is the reason U R Rao Satellite Center, along with the Jawaharlal Nehru Planetarium, Bengaluru, thought it is fit to celebrate, even though it is a holiday, middle of the long weekend, to celebrate it here amongst students and children, so that this message of looking up at the future and work towards that is what is going to bring us glory and success. This is a small step that was taken in the early 1970s, which succeeded on this very day 50 years ago, has resulted in what? That is what, if you look around, we have more than 30 satellites launched, working. More than 50% of them are still working, and we have at least 100 rocket launches have taken place around the country, carrying various of our own satellites as well as some of the foreign countries' satellites. And the national economy and communication environment has been revolutionized from a poor country which was no different from today what we call as the sub-Saharan country economies, which is no better than that it was in the 70s and 60s, has become, he is now trying to become the fourth largest economy of the world. All this is not only because of the space program, it is the thought behind the space program that has made this possible. In fact, I want to remind the people that there are 3 events in the 1970s which, in my opinion, were responsible for the rise of India and the continuing rise of India. The first one is the 1971 Bangladesh Liberation War, where decisively India won the war and created a free nation called Bangladesh. Number 2, in 1974, the first nuclear test was carried out by India in the deserts of Rajasthan at Pokhran. And the third was the Aryabhatta launch in 1975. These are symbols of a rising power which dares to imagine that we can get rid of our shackles of poverty and work towards high economic prosperity as well as technological superiority. These are the 3 events which happened in the early 70s, which has deeply affected the psyche of many young people at that time, which made them to believe that it is possible for us to do things which we are only hearing from others as it is possible they have been doing. So India as a nation was able to rise above its immediate problems, and the outcome of that we are seeing today. Now, having done this, what has been done, is it sufficient? Is it what adequate for us? Whatever has been achieved, is it adequate for us? The answer is a big no. That is the reason we thought at every available opportunity we need to bring up this point and remind our younger generation that there is still a lot of work needs to be done, because the problem of this country are unique. It is not like any other European or other Western countries, because ours is a very diverse nation, very large nation with a huge population. We are having 1/5 of the world's population, more than 1/5 of the world's population today. And from the sheer size, it is bigger than many countries, but for the population, if you take, the area is very small. So the available resources, if you per capita, if you divide, is not very high. That is the reason why this generation and every upcoming generation needs to think about, needs to imagine how India has to progress in future, how we can contribute towards that progress. Because without risk, without any adventurous risk taking, there is no major benefit going to come. If you have to be conservative and do the known and repetitive things, the results are also going to be known outcome and repetitive outcome only. Where when we dare to imagine and move away from the beaten path, so that you create your own new path for wealth and prosperity and peace. That is the message we wanted to convey through these outreach programs during this celebration of the 50 years of Aryabhatta, which has been ably orchestrated by our team over here, led by Dr. K.V. Shri M and Dr. Rajendra. And now in this event, we have been supported by the Jawaharlal Nehru Planetarium, Bengaluru, led by Dr. Gurup Prasad, who is one of our own. He continues to be our own person even today, even though he is no longer in ISRO. And it is an opportunity for us to tell you this story back. It is like your grandparents or some old person at home telling you how your family crossed certain difficulties, how they excelled. It is that kind of feeling. With that only we are all here, that ISRO and the satellite program of ISRO are our household story, which we want to keep reading and reciting again and again, so that we learn from the spirit of innovation and excellence from the Aryabhatta team. In fact, those people who have worked with Professor U R Rao will many times recall and tell that very famously he has been quoted saying that if something has been done by somebody, we can do it better. That is the mantra we want to pass on to all of you, my dear young friends, that there is nothing we cannot do. If you put our mind to it and work towards it, there is nothing we cannot do. And India is looking up to you, the younger generation of this country, and the upcoming generations, to fulfill this dream of us, that like how today India has become one of the leading space powers in the world. This is only a very small segment of the national activity. So maybe one among five, India has become among the world powers in the domain of space technology. And it is essential that we achieve this kind of advancement in not just only in this area, but in all other areas of activity. Let it be education, let it be technology, let it be environmental protection, let it be social engineering, let it be anything. It is essential that we cannot become happy just becoming good in one area of our national ambition, and this is all the responsibility of all of you. The older generation to us had passed on certain legacy to us. With our own abilities, we have tried to carry this forward, and now we are looking at the next generation of people who will carry forward this legacy, so that India reaches its well-deserved position among the community of nations. It is all up to you. Today we have three eminent speakers who are going to speak to you on this celebratory occasion, and also remind you what it means for all of us when the Aryabhatta was successfully launched, which was expected to work for 6 years. And Dr. Alex last time he mentioned that it worked for almost 19 years, which is, they are going to tell a lot of such stories to you so that you can get inspired and lead this country forward in not only in the domain of space sector, but also in all other domains of economic, scientific and other activities. Thank you for joining us today, and let me also thank Planetarium staff for organizing this event so well. Thank you very much for all of you, and Jai Hind.
Thank you so much, sir. We are grateful for your presence here and for sharing such a compelling inaugural lecture with us. Sir, now I request you to kindly hand over the mementos to the dignitaries on the stage. Professor Annapurni Subramanyam, Director of Indian Institute of Astrophysics. Shri A.S. Kiran Kumar, Sir, Member, Space Commission and Chairman, Base Council. Dr. T.K. Alex, former Director, U R Rao Satellite Center and Vice Chairman, Base Council. To Dr. B R Gurup Prasad, Director, JNP. I now request our Director, Dr. Gurup Prasad, to kindly hand over the mementos to the dignitaries. To Shri M. Shankaran, Director, U R Rao Satellite Center. Next to Dr. Shri M, Director, Laboratory for Electro-Optic System, AOS, ISRO. Sir is also the chairman of the Golden Jubilee Celebration Committee. Next is Shri A. Rajendra, Deputy Director, URSC Mechanical Systems Area, and also the alternate chairman of the Golden Jubilee Celebration Committee. Also to Professor Madan Rao, I kindly invite him on the stage.
This memento is none other than a small model of Aryabhatta. Thank you.
Thank you, sir. Now I request the chief guest of today's program, Professor Annapurni Subramanyam, Director, IIA, to kindly address us.
Namaskara, good morning. I thank Jawaharlal Nehru Planetarium and the URSC for inviting me here to give my few words on this occasion. I also, dignitaries on the stage, off the stage, the various members of ISRO, and my dear students. So I'm standing here as one of the, person who has used the satellite program, and I'm a beneficiary of it. So standing here as a beneficiary, I just wanted to convey a few thoughts which is coming to me, like what did I learn from this and what is that which I will take away from here. And I think for the students there will be a lot of advice coming on towards you, saying that you expect this, that, etc. From your point of view, what is that you are looking forward to, right, in your future? How you can, how this can benefit you. So let me put these kind of arguments and give you a kind of a thing. So when I was a student like you, when I was in school, and I was in a government school, so what I could look up to was newspaper articles. If it is a few newspaper would tell us about what Aryabhatta is about and how the satellite was there, and a few documentaries in our Doordarshan news. Nothing was there beyond that. So getting interested in things and wanting to know more, there was scanty of information. There was no information. But if I was like, I mean, right now, if as a child, what is that for you? There's a lot of information out there. There's plenty of information. In fact, it's an information deluge. But if I was to go through this deluge and try to find out what is important to me, I'm getting lost. But you people have been born in the era of information deluge, and I'm sure you're able to understand and assimilate information which is useful to you and discard which is not useful to you. So that's point number 1. 2, even in that situation, I was quite mesmerized by the night sky. I would go out and look up at the night sky, and thanks to our power cuts, we used to have completely outage of power, and there was no power, and the sky used to be really beautiful. Nothing else to do, you can't do anything. So you try to enjoy the sky and try to do things. So opportunities like this, you would think is a disadvantage, but it can be a various disadvantage to you, because any disadvantageous situation is presenting an advantage to you, but you should be smart enough to figure out what is that is given to you there. So you should pick it up. And if you're interested, pursue it. And the programs like this also teaches you one more thing. Has anybody did Aryabhatta-like thing before? No. People who are working on this kind of systems, have they done this before? No. Have they got experience before? No. So how do they take this up? Can you do it? Will this lead to a success story? What is there for me at the end of the road? These are not the questions which are asked at the beginning of the journey. The journey is taken because it excited them and they really want to do it. Of course, nobody has done it before. This is the first time everybody is doing it. Everybody is ready to face failure. Everybody is ready to face a setback. What is important is that setback is not telling me, oh my God, this didn't come today right, I'm not going to do it tomorrow. No. What is understood is this: if it is not working today, it will work tomorrow. What is that I have to do it right to make it work tomorrow? So what I have learned today, it's not working, is important for me. I'll not make the mistake again. I'll do it again tomorrow, but it is going to work, right? So that is the approach that has been taken, and that is the reason why they have made it. And for me, the intake was that if I couldn't do it today, I'll try tomorrow. And how will I know whether I'll be able to do it or not? Only by trying it. So I think it's important that if any opportunity comes to your way, you should try it and see whether it is working or not. It may not work, you may fail, but that doesn't matter, because that gives you more understanding of how to wade it through to make it work, right? So I also had problems like, can I write an entrance exam and qualify? I do not know. How do I know? Write it. You may not win for the first time, but the second time you will do it. You'll make sure that you want to do it. You'll make sure that you can do it. So that kind of a temperament is extremely important for projects like this. And for me, when I started working on astrophysics, I did not know what this astrophysics meant. I wanted to do something with stars and space. So when I said, okay, astrophysics is the opportunity you have, I jumped in. Then I started learning things and doing things. So many of the time we will be encountered with a situation, you have not done it before, can you do it? Okay, let's try it. That's the only way you can move forward. Now, why am I saying this here? Because I have used this and I have been successful in some way or the other, becoming the director of IA, where I did my PhD itself. So that was the training ground. This country has given me the education. This country gave me the training ground for me to advance forward and reach a certain situation. So that is why I'm telling you this road taken may be, it was useful for me, I'm sure it will be useful for many more people to come. Now, where are we now? In the last 50 years, and we have gained a lot. And so when we started from the ground, there was nothing there. But right now we have a lot of things. Now space technology is something which is a common word for everybody. And without space technology, no country can exist. That's become one of the necessities now. And we in the country have good information network, good network of people whom you can talk to, you can learn about, and you can pursue your dreams. And talking about dreams, nothing will work without dreaming big. If you can say that what is it you're going to do, gain at the end of the road, you cannot predict. The journey itself is going to give you a huge amount of experience, and that will give you a lot of opportunities as well. So don't ask questions of, what do I get at the end of the road without understanding what is the journey about. The journey gives you a lot of experience. Like, if you go through this itself, this kind of experience itself, I could never imagine when I was a student. So these experiences, these interactions give you a lot of opportunities to think, dream, and work towards. So these opportunities, like these events which are organized, are very important because somewhere something will stick to you and then it will help you to move forward. And for me, I have used and also worked with the AstroSat, which is one of the first Indian space observatory launched by ISRO in 2015. It is actually later this year, it is going to complete 10 years in orbit. The nominal lifetime was 5 years. We have exceeded it, and we are continuing to do science with it, and it's in the 10th year now. So these, I was a calibration scientist on the UV imaging telescope, the ultraviolet imaging telescope. This is the first time I worked on ground telescopes, and I had never worked on ultraviolet. I have not worked on any space telescope before that. It was the first experience for me. It was extremely challenging. So many times I would be like, choking or suffocated. I don't know how to take the next step forward, but those experiences are extremely important because after you take that experience, you look back, you're a different person. And so those experiences are really, really fortunate to come by. And I also have seen the Aditya L1 mission launch, and we contributed one of the important payloads to it. We go through very difficult times, tough times, but they really help you and mold you to move forward. So whenever you get exposure or opportunity to do it, please take it, because you don't have to worry about failure. It's part of life. You fail, without failure is no success. It'll be part of you, but you just move forward. Success is always there. There's always light at the end of the tunnel. It's a difficult path, but it's worth taking it. And it'll take you to some area where it just never ever explored before. So that's amazing, and that's what is driving me, because the space, the unknowns there. Why am I doing it? People sometimes, when I was young, used to ask me, why don't you take a job where you get money? But am I happy at the end of the day when I get a large amount of salary? No, I'm not. I'm happy when I'm doing something and I'm learning something. Wow, it is really nice to know this is how it works. That's what makes me happy. So there are several experiences you get out of it. So that's what my take of this entire journey is about. And the ISRO as an organization has provided extremely large number of platforms now. It's a very big success story. And for us, which is a home institution, it is equivalent to NASA. NASA is there for the US, but for us it's ISRO. And also the success stories, the technological advances, the challenging missions it has taken forward, and the future missions which is coming up, they are extremely exciting, and there are a lot more opportunities for us to do it. Apart from that, the space sector, the new space policy, and the opportunities for the industry and the startups, etc., is also expanding. So the new generation, you're not looking at a traditional way of doing things like when I grew up. So you have much more different opportunities. The landscape is completely different. It's just your dreams, your aspirations, and your way of doing it. So you can just do it, go ahead and do it. The platform is given to you as a silver platter. So that's where you're starting. You're not starting with the earlier struggles which this team, the Aryabhatta team, started off with 50 years ago. So you have a very different platform. You have a very different, the network, the facilities given to you. So you take it from there and take the stream forward in whichever mode you take it. So that's where I would like to stop. And for me, like wanting to see the next generation taking it forward in a completely different manner, but in a very challenging way, to explore space, explore technology in whichever way it's not done before. We'll be extremely happy to see it. I look forward to see the bright future. Thank you.
Thank you, ma'am, for such a thoughtful and inspiring speech. Now I request Shri A.S. Kiran Kumar sir, Member Space Commission and Chairman of our Base Council, to deliver the presidential address.
Good morning to all of you. Good morning. Yes, some energy there. Thank you. See, it's indeed a very happy day today. As was pointed out, it was exactly 50 years back on this Saturday, April 19th. You already saw how the Russian rocket took Aryabhatta into space. And before that, you saw how the activity itself started. India, probably I'll just go through a couple of question answers before I get into this. When was a first object put into space by human being? Which country did it? Russia. And what was the object? Sputnik 1. And which was the year? 1957. And 1957 was after how many years of our independence? 10 years of independence. As already pointed out by Shankaran, see, India was a fledgling democracy which got its independence in 47 after many hundreds of years of external rule. So obviously at that time, what do you think was the problem the country was facing? The governments were struggling to provide food, shelter, education to its citizens. So at that time, if somebody were to talk about, we want to do space program, you can imagine what would be the thought process or response. But like Shankaran pointed out, it is only when great visionary people look at how you can make changes in the society or changes by adopting newer ways of doing things. So we had a great visionary scientist at that point of time, Dr. Sarabhai, who said, if India has to progress, we have to adopt space technology. And for that, he initiated, and one of the persons he had chosen for doing the task of building a satellite was Professor U R Rao. Probably in one of the later videos you might see that, how Dr. Sarabhai asked Professor Rao. And when Professor Rao started the work here, practically nothing existed. You saw also already the sheds in Bengaluru, Pune, how a newly constructed industrial shed was converted into a place where a satellite can be built. In fact, I remember in 1975, after the Aryabhatta launch, Professor U R Rao had come to Indian Institute of Science. I was a student there, and in the Senate Hall, he was giving a talk after the Aryabhatta launch, telling about the Aryabhatta payload, Aryabhatta performance. In fact, it was that event which inspired me to join ISRO. I joined Ahmedabad in 1975 August. And if you look at what Aryabhatta itself did in the country was, it created a pool of people who could imagine and bring it into reality a capability of building space technology competence in the country. Today, you see, India is, as already pointed out, is among the 5 top countries, and very soon it will become one of the top 4 countries with humans going into space and coming back by our own launches. And India is also aspiring to put its own space station by 2035 and wants to land humans on moon and bring them back by 2040. So you see already India started its program early 50s and 60s, And I'll just give you a couple of examples of how it has moved forward. Aryabhatta itself, as was pointed out, you will hear some more details of that through Professor Alex. After Aryabhatta was launched, India started its journey in remote sensing with Bhaskara, probably in the upstairs exhibition. Through the panels, when you go through, you will see how step by step India developed its competence in space technology, starting from building rockets, satellites, applications, whole lot of these activities. But in all this, what is very important is both Shankaran and Professor Annapurni pointed out that it is your ability to look beyond what is happening today and how we can make use of technology for addressing many of the problems. For example, India tried to solve its problem of communication, broadcasting, remote sensing, navigation, all of that, when it encountered very specific problems, brought in solutions in a manner which is very different from what the rest of the world has done. In fact, you will be happy to know that India is the only country which started its space program for non-military activities. Every other country started its space program only to demonstrate their capability and might as a military nation. And why was India doing this? As was pointed out, it is because it was trying to regain its position, which was, probably some of you know, in the early millennia, where do you think India was? Was it at the bottom of the table or at the top of the table? Top of the table. So, and from top of the table, when it had come down, it resumed its journey after independence, and now today you are the largest economy. Fourth. Very soon you want to become first. So how can this happen? This can happen only when we put in our effort, make things differently, and world is moving very quickly. You have already seen that today the kind of technological tools that are available are so much advanced that human requirement of making use of his own physical strength has reduced drastically, and very soon people are trying to replace your asli intelligence through artificial intelligence system. So all of you have a challenge. People are telling you that jobs will be difficult, this will be difficult, but then should you be worried about it? Yes, you should not be worried about it. So what should you do? Yeah, you should make use of whatever tools that are available to you and do things differently from others, and in the process not only build your capability but also show to the world that you can make a difference. You saw, for example, India demonstrated during COVID times a very unique thing. COVID, probably you know, the situation where everybody was looking at how can we take advantage of this economically. While everybody else was trying to get economic advantage, India not only solved the problem for itself, but also gave these solutions to others, not for economic benefit. And similarly, you have seen how digital stack system is breaking the backbone of credit card and financial system. Today, probably you may not be so much bothered about what is happening, tariff war, etc. But in some way it is going to affect your lives. But then what you should be worried about at this point of time is enable your own ability to learn things, learn the process of learning, improve your skills, make use of whatever technological tools that are available to you, and show to the world that India can be very different and it can regain its position of being on the top of the table. And if that has to happen, few things which we need to remember. What is happening today? Today we are remembering what was done way back in 1975 by a team of people who did not have any first-hand experience of building a satellite, and then they built it, launched it, and paved the way for a journey where India meticulously moved forward from Aryabhatta to Bhaskara to Apple, communication, remote sensing, navigation, satellites. And even while doing all this and while building its own capability of launch vehicles, it started with taking whatever help it could get from other nations, but quickly established its own ability. Same way, what you are required to do is learn from whatever means you can get, know about things, but use those tools very differently from what others have done. Then only you can showcase to the world different things. And if you see the examples, India, when it was not getting its cryogenic engines, it built indigenously cryogenic technology. And while it was building its launch vehicle, it also demonstrated that it can do things differently from others. You saw in Chandrayaan 1, though man had landed on moon and a large number of probes had touched the surface of the moon, Chandrayaan 1 gets the credit for discovering water. And then similarly, when Mars satellite was put into orbit, India became the first country to put an object around Mars in its maiden attempt. So like this, if you look at, ISRO has demonstrated that you can learn from others, you can learn from not only your mistakes, but others' mistakes. But then if you make use of that knowledge and learning ability, you can build things where others will look at you and see, wow, how are they able to do it? And if this tradition has to be continued and it has to move, and if India has to regain its position before 100th year of our independence, what we are expecting is all of you who are participating in today's program here, learn from not only the mistakes we have committed in the past, but also look at what others are doing and how you can overcome those and build systems and provide solutions to not only India, but also to the world. Today you have seen that going to space gives a tremendous advantage, because when you start looking from Earth, many times the atmosphere comes in between you and the celestial object. But if you go beyond Earth, that atmosphere is not there, you are able to see better. And that's how Astrosat, Aditya, or many of these satellites are able to make observations. And today, for example, you also know James Webb Telescope is one of the best observatories operating in space. Human ability to understand the universe depends on observation and then enhancing our ability. So all of you who are participating in today's program, I would suggest you just go through the material that is presented to you, both in terms of posters, and also you will have an opportunity in the afternoon to interact with a person who can be the likely Gaganaut and experience in future going to space itself. So make use of all the opportunities you get and keep asking questions till you are satisfied. And if nobody else has answered it, you answer it, and that is where you can make a difference to the world. Wish you all the very best.
Thank you, sir, for such an impactful and thought-provoking speech. Now I call upon Dr. T.K. Alex, who is a veteran of the Aryabhatta program himself, to share his reminiscences of Professor U R Rao.
Good morning to you all, dear children, teachers, and all the dignitaries on the stage. Welcome to JNB and to this function. So we all have assembled to celebrate one of the greatest technological events of India that happened 50 years back. On that day, India entered Space Club. and develop is a club of developed countries. Suppose you have been a space club was only for developed countries, but a developing country like India also entered. We have launched the first satellite. India named the first satellite Aryabhatta to remember the greatest mathematicians of India. You know what is, any of you know what was special about Aryabhatta himself? He is the greatest scientist. Any one of you can tell? Yes. Okay, good. So he wrote a book about science, whatever he has found out, mostly on astronomy. Okay, the book was not very big. It had only 4 pages, but it was full of slogas in Sanskrit, small slogas written. Each one was like a mathematical theory. If you read it, you will understand. It contains including calculus, algebra, and the like. So aptly we named our first satellite after the great scientist of India, Aryabhatta. I was very lucky to be a part of the Aryabhatta team, which developed the satellite literally from scratch. I was a member of the launch Thank you. I was a member of the launch team as well. We were taken to Soviet Union. Russia was called as Soviet Union at that time. We went to Moscow first by plane, and from there we were taken to a place called Volgograd. It is a place down south near Caspian Sea. From the airport we were taken to a military town called Kapustin Yar. It's a place where the satellites were launched, rockets were launched, missiles were launched by Russians, one of the launching places. And those days was a place, a period of Cold War, Cold War between America and Russia, and they owned, each one of them were very, very secrecy, and nobody has seen that launch place at all. We were the first foreigners to go to that place. All activities were totally controlled. We stayed in a hotel. The strangest thing was, as soon as we entered the hotel, they closed the doors and 2 security men will be standing at the door. We are not allowed to go out. Similarly, we go to the laboratory. Same thing, we enter the laboratory and the doors are closed and 2 security men with a gun are standing there so that we cannot go out. We were all youngsters. Average age was 27. I joined the ISRO at the age of 22, and we were like school children or college students on a study tour to Russia, and there was one headmaster with us who was the leader of the team. The leader was Professor U R Rao, Udupi Ramachandra Rao. He was truly a headmaster. He was not a scientist for all of us. He was very strict in his activities, but he was loving the students. We were all like students. We were staying in that place for almost 30 days. The temperature was minus 30 and the highest was minus 15. We were all carrying with cords, and they gave some woolen material. And the launch, previous day of the launch, 18th of April, the rocket came there. Rocket, they bring it on a rail, like a train. The whole thing is brought in a horizontal form. The whole rail is coming through the lab. So they stopped the rocket, and we were ready with the satellite. Satellite was taken from Bengaluru to Moscow by a plane, a cargo plane. And the satellite was assembled with the rocket horizontally. And then it was closed, and next day was the launch day. Okay, it was a Saturday, I sort of heard. And we were all standing about 3 kilometers away from the launch pad because of the dangerous place. And we watched the launch. The first time we heard the familiar countdown. Now everybody knows what is countdown. So we heard through the mic 10, 9, 8, like as 0. We all experienced the actual launch of a rocket and a satellite. It was a beautiful experience. Everyone jumped with joy. The event was witnessed by Professor Satish Dhawan, Professor U R Rao, and Ambassador Dar, and many Soviet military government authorities, including mayor of the city, generals, It was a big thing. It was a grand success. So the launch was success. They announced. Immediately we rushed to our laboratory. Inside laboratory, we had some equipments for testing the satellite. A transmitter, receiver, antenna, all were there. The previous day, we had hooked up everything on the top of same building where we were testing. And we turned the antenna. It's a Yagi antenna, aluminum rod-like thing. So we turned towards the expected location of the satellite where we are supposed to come. So within 1.5 hours, suddenly the signal started coming through the thing. So we were all just jumping. And the printer started giving the output of the satellite one after other. The printer was not very big. Its printer looks like what you see as a printer in your supermarkets, or the bills are coming. That was the type of equipments we had. We were making the satellite at the period. In a satellite center, there was no computer, no PCs anywhere, no mobile phone. Anyway, mobile phones were not invented those days. To make a telephone call, we used to go to telephone exchange and book a call to so-and-so. I want a call to Trivandrum so-and-so number, and wait there. After 20 minutes or 30 minutes, the operator will connect to you. That's how the telephones used to work. That was the time. And we didn't have any calculator to make any calculation. Forget about the PC, not even electronic calculator. But we had a very interesting equipment called a slide rule. It looks like a scale. It can be slide up and down. We can do multiplication, division, exponential, sine, cos, tan, theta, all sort of things we can do with that equipment. We all had one of such things in engineering colleges. We are doing all calculations using these slide rules those days, in the 70s. Within 4 or 5 days, calculators came. Then after a few days, the PCs came. That's all story, you know what happened. Anyway, most important thing, there was no internet. And no way to get information from anywhere. And I joined a division called Satellite System Division. Professor U R Rao was the head of the division. So I was assigned to make an instrument called magnetometer and sun sensor. Magnetometer is to measure or find out the direction of the scientific payload, where the instrument is looking. Once you go to space, you don't know the directions, where it is looking. So I was supposed to make a magnetic sensor, magnetometer, like a compass, electronic compass. I never worked on that thing. I came directly from IIT Madras, joined here. I never heard about satellite. Okay, none of us had any experience. Like me, there are about 30 people in Trivandrum, all fresh from the universities or IITs. None of us had any experience. And similarly, about 20 people were in Ahmedabad. They also didn't have any experience. We were told to make satellite and instruments. Professor Rao divided the work. You make the structures, you make the thermal system. I was assigned to make a magnetometer. So one day I asked him, when I met him, so what is the specification for which I should work on? So he didn't think much. So it should be the best magnetometer in the world. That's all. So it is my job to find out who makes the magnetometer. Nobody makes it. Nobody in India, nobody makes. The USA also, no way to find out. Some journals are there. Luckily, there are some NASA's old journals were coming in the library. It was helpful. He scanned it, found out there is some magnetometer being used. Later I found out Professor Rao himself is a specialist in magnetic field measurements. So his story I will be coming later. So he was an expert. He used magnetometer, but he was not telling me the specifications. He told me to find out. So from journals and other things I made. Within about 3 months, I could hook up from fundamentals, how to make a magnetic sensor. And I showed him. He was very happy that at least I could make and show a working magnetometer. And later we could fly it in the first Aryabhatta satellite. And we could find the direction of the astronomical payload which was looking up in a difficult situation. And the magnetometer was used successfully to look at sky and the X-ray payload, what Professor Rao and Dr. Kasturirangan developed, that could look at a X-ray emitting source in sky. And a paper was published on that in the most prestigious journal called Nature. So that was the thing. Although with a short mission, scientifically, and the results were published in internationally the best journal available. I could be part of that thing, finding out the direction of his payload looking at the sky using my magnetometer. That was my contribution. And initially we were working on a satellite. That was the task given when we were in Trivandrum. I joined in Trivandrum first, and then we moved to Bengaluru. And we were told to make a 40-kilogram satellite for SLV-3. SLV rocket was being thought of at that time. Nobody had made it. So we were making a small satellite. Then the Russian offer came. They can give a free launch, but the satellite could be bigger. So we expanded the scope to about a 350-kilogram satellite, and with scientific instruments. That's how the Aryabhatta was born. So let me come back to Professor Rao, my headmaster, who was teaching me all the things. He was a versatile space scientist, a technologist of excellence, a passionate space application person, all rolled into one. He had very sharp analytical bent of mind, enormous intellectual abilities. He had back of grasp of the contemporary happenings, astounding ability to make a quick back of the envelope computations. He also didn't have a calculator or anything, but he had some paper he will write on the back, and that will be right. So where he got all these things? Professor Rao was born in 1932 in a village called Adamaru near Udupi district. There were not much of educational facilities available. There was a small high school, a Christian high school where he did his schooling. The family was not very economically, not very bright situation at that time, like many of the families around those days, 1930s, 40s. It was all difficult situation for the entire country. But he was studious, but he had difficulty with maths and physics. So you can imagine, even in the schools, he was not the best in the class. Not necessarily you have to be best in the class to be the best scientist and achieve the best in the world. So anybody with the small difficulties also can climb the ladder and go to the topmost positions. His family didn't have much of financial resources, but he was thinking that he should do the best of science. He had a scientific mind how to do best. His father was Lakshmanarayana Acharya and mother Krishnaveni Amma. Their financial situation was pretty bad. After completing 10th, he went for Madras University for his BSc degree, and it is master's from Benares Hindu University. Interestingly, there is another big scientist in Bangalore called, by name, Professor U R Rao. He was a contemporary of him in this BHU, but the U R Rao did there is a master's in chemistry. Professor Rao did it in physics. So sometimes he will say physics is better than chemistry. They used to talk each other like this. He joined a physical research laboratory in Ahmedabad. So that is actually the starting point of most of the space activities. This laboratory was started by none other than Vikram Sarabhai and his family. He worked for the PhD degree under the guidance of Vikram Sarabhai. That was the biggest advantage he got. He got his PhD from Gujarat University, and Sarabhai was his guide. So that made the starting point for him. He chose the right place to work initially to get his degree. Later he got an opportunity to go to US, and he got a postdoctoral opportunity at MIT, USA, and he started working on astronomical problems. And one of the problems he worked was on magnetic fields, not the magnetic field around Earth. What is the magnetic field beyond Earth? Beyond Earth means the interplanetary area, whether there is a magnetic field and how the magnetic field comes there, what is the origin of it. That was his quest. So he worked on that thing with big scientists in the US, and for that he did work on magnetometers and other things. So he worked on the early US satellites called Mariner, Pioneer. Some of them went 30, 40 years, they were flying beyond the solar system. Some of them went beyond the solar system. They were primarily measuring the magnetic field, electric field, and particles in those areas. And that will give some idea about the nature, how was universe formed. So that was the type of quest he had. So he worked on that thing. That was his background. And he came back to PRL, or Physical Research Laboratory. He became an associate professor and became a professor there. And that's why we all call him as Professor U R Rao. Okay, so the professor position he got from PRL Ahmedabad. And finally, he himself became the chairman of the PRL Council. So he became the top man in the PRL, so in the later years. When the Aryabhatta project started, he was designated as a project director. He worked as a project director, and he was a very special project director. As I told, we won't call him as a project director, he was a principal or a headmaster. He was very strict in all activities. Finally, this project grew in size, number of people. We were only about 200 or 300 people. Finally, it became a ISRO Satellite Center. Dr. Shankaran is here. He is the present director. About 3,000 people are working there. And Professor Rao was the first director of the Satellite Center. And later, he became the chairman of ISRO. And he held many positions. He was a member of the National Security Advisory Committee, member of the Space Commission, chairman of the Prasar Bharati controlling our All India radio and television systems. And there are many positions he held. I will not read out everything. He was as a manager, he was a tough taskmaster with a deep insight, abundant enthusiasm. About his schedules, time schedules, and budget management, you already heard. He is very tough in that, but he was considerate to people. And we were all asked to make the best satellite possible, and no errors are allowed. So when you make printed circuit cards or electronics, normally we make mistakes. So when you are going to fly into space, there is no scope for any error. So we make the printed circuit cards should be the best in the world. So we made printed circuit cards in a factory called Hegde and Gole near Hosur. And the cards were brought to Bangalore. All the cards were gold plated in Bharat Electronics. So that is the highest quality of printed circuit cards. And I'm really glad to say that all the printed circuit cards worked very well. And we never made such beautiful cards in the later any of the satellites. And that was the best we could make. We made not only one satellite. So initially we made a small satellite about half a meter size. That we hung from a balloon from Hyderabad. There is a balloon facility in Hyderabad. So the balloon is not small, it's about 1 million cubic feet it can grow. It contains the hydrogen inside. Fill it, early morning we launch it. It goes to about 30-40 kilometers, and with the wind it goes. Whole idea was to check the communication. So communication signal comes from somewhere away. So it moved away, it went up to almost Bengaluru side, and towards the north side it went. And then a command was given, it cut from the balloon, it fell down. It was collected back. So later another satellite model was made. It was taken to Sriharikota. It was hung from a helicopter. Helicopter went around and we checked the signals, and the signal was very good. Then we made one satellite called a prototype satellite, a fully functional satellite, but we tested fully. Later we made the flight model, actual thing to fly. So Professor Rao was not happy with one. He said, why don't we make one more satellite called flight model 2. So this all we made in 2.5 years to 3 years time. That's what Dr. Shankaran was telling. It is unimaginable at today's working environments. So we could make in 3 years more than 5 working satellites we could make it. The first flight 1 was taken to Russia and flown. Flight 2 was kept here as a contingency. Okay, in case of some problem, we could fly the second one. So after launch, the second one was available. So what was decided was the scientific payload was removed and the camera has to be put. That is the time Mr. Kiran Kumar joined ISRO. He said he was in charge of the camera in the second satellite. Second satellite, we named it as Bhaskara, Bhaskara 1. And Bhaskaracharya is another great scientist of India, master mathematician, astronomer. So that satellite was named after him. And the second satellite contained the camera made by Kiran Kumar and his team, which also worked very well. Then remaining is a story of ISRO. I will not tell that. When you go upstairs, you can see Aryabhatta, Bhaskara, Rohini, so many satellite, communication satellite, etc. you can see. This satellite, Aryabhatta, contained 3 scientific instruments, and one of them was specifically designed with ideas from Professor Rao. And after the launch, we had some hiccup in the overall satellite. And later, not only the scientific instrument, they did some experiments with the rocket, with the satellite. It was used to send a signal from Sriharikota to Bangalore, because satellite has a receiver and there's a transmitter. So it was decided that a signal, some signal will be sent from Sriharikota to satellite when it goes over India, and antenna in Bangalore will receive it. So that was the start of a communication. Communication, how satellite can be used for communication. The US had communication satellite, but India didn't have an experience. So first communication experiment was done through Aryabhatta. And what was the signal sent through that? It was an ECG signal. ECG signal taken from the doctor in Sriharikota that was recorded in a tape recorder. It was sent from there to here. So that was the starting of a telemedicine, experiment on telemedicine. So Aryabhatta was not only a science experiment, it did technological experiment to show that we can send a signal from a distant place to other place, and it has got application like a telemedicine. They were demonstration at that time. Within a few years' time, we could send the satellite called Apple, which was a full-fledged communication satellite, and that was used for our television distribution in India. First television we could show through the Apple satellite. Later, InSat series and a number of communication satellites were launched. All of you are getting the advantages of the communication satellite. Later, internet, all the systems have come into being. Professor Rao, when became chairman ISRO, he had to face a lot of difficulties in development. The most difficult thing was what's called as sanctions. Sanction is imposed by foreign countries. They will not give advanced technology, materials, components to India, because we have launched satellite, we have made a nuclear device explosion, because I think they banned India, and specifically ISRO and Atomic Energy Department, they will not send anything. Not even electronic components, any components for satellite, metals, epoxies, chemicals, all were banned for ISRO. It was a real challenge, because none of these things are made in India. To how to go about doing the our satellite building. So this was a real challenge for Professor Rao. But he is not a person who will not back out. So he found out we can do everything in India if we have the will. We can make a satellite, we can make the components as well. So he started a big activity called indigenization of components and materials. So the present government says making in India is a big activity, but this making in India activity started about 25, 30 years back in ISRO's initiative for ISRO's activities. We could develop different type of metals, alloys, okay, very high strength aluminum, maragin steel for rocket body, and large number of chemicals used for rocket fuel itself, and all the electronic components, including the microprocessor, what is used in PCs. Even those components could be made in India. So we could, our aim was to make a full indigenization of these devices, and we could make a good progress. And the present government is encouraging this activity not only in this devices, etc., in all areas. Making India has become a slogan for the country to go forward. Space technology applications is another area Professor Rao worked very well, and that was his pet subject. Satellite for not only for demonstrating technology, it should be useful for the citizens of the country. His knowledge about how it can be used for number of applications, forest cover mapping, wetland mapping, Rajiv Gandhi drinking water mission, flood mapping, national agricultural drought assessment, integrated mission for sustained development. A series of development activities are going in the country, but satellite-based imagery or pictures are the baseline for this one. Whole India was covered by India's remote sensing satellite of different colors or spectrum, we call it, and that is used for assessing our own country's wealth and also warn the citizens about the floods and the weather disasters. All those things could be done using satellites. And the application of satellite for radio and television broadcast is known to everybody. The latest thing was the introduction to navigation. All of you are familiar with the GPS in your phones for location finding. You know that we have Indian-made GPS, equivalent to GPS, what's called as IRNSS. Okay, using the Indian system, we can do the navigation as good as the GPS, and it is not used in the normal phones, but are some specialized phones used. The primary use is the military. When there's a military activity comes, the GPS will not be working, at least may not be working accurately. So we can depend on our own navigation systems. So Professor Rao was not only looking at this, the technology, etc., growth. So he was in his mind, or in the back of the mind, he is a true space scientist. His initial studies on Pioneer, etc., in USA, and later the experiments in Bhaskara, that thought was in his mind. Later the Astrosat mission came. It's a astronomical mission with all-in-one, 3 instruments together looking at astronomical object. So Professor was very critical about each of the instrument, how the specification should be, what should be the aim of the experiment. He was behind the things. And when Chandrayaan-1 launch and success came, he was behind, and all these Chandrayaan-2, all of who are familiar, I will not go through those details. And one of the pet subject to us, he was looking at the sun, our own sun. Sun has got what's called as a corona, that is enveloping the sun. Professor Rao's speciality is in the magnetic field, and how the magnetic field comes from the sun through corona, or the waves from the sun. So he was very curious about it. And what is the curiosity? Curiosity was the sun itself, if you look at it, the surface temperature is about 6,000 degrees. Okay, it's not very high, but very, very, very hot. But the corona temperature is 1,000,000 degrees. Corona comes after the 6,000. The question is, 6,000 is below, but corona is much more high temperature. What is the cause of this? This subject is not yet solved by anybody. This 1,000,000 degree, where does it come from? Many theories are there. I met Professor Rao about a month before his death. He came to the office. He was looking at some papers. I asked him, what are you looking at it? He said, I am still worried about this particular problem, how the corona's temperature can be of 1,000,000 degrees when the surface is only 6,000 degrees. Even in his later years, he was worried about such a problem. And other subject he was looking at is the astrobiology, whether life exists beyond Earth and other places. India did some experiments, and he is very particular. As a scientist, many times scientists get some result, initial results. The immediate interest is somehow publish a paper. So he will not do that. He will advise his colleagues, never publish unless you are very sure about it. This astrobiology experiment was like that. We got some signals, telling some bacteria lives about 30-40 kilometer above the atmosphere, but he was not satisfied. He said, you show more than once such bacteria exist, and that bacteria is not from the earth. If it is from the earth, any of the bacteria, he will not accept that. So it is a tough job to given them. Similarly, we had an experiment in about a solar experiment done in 1980 from Hubli. There was a total solar eclipse. Eclipse time we can see the corona. So sun's corona alone we can see without seeing the sun. So the experiment was, Professor Rao put the theory that sun also may have a ring around the sun. Like a ring around the Saturn and Uranus, there may be a ring around the sun itself. And if it is there, it will be at 4 times the radius of the sun. So an experiment was hooked up. I was part of that experiment. We conducted an experiment, and indeed we got a signal at that place. There is a ring around the sun. There is a signal, infrared signal was there. We shown to Professor Rao. He is not satisfied. He said, don't publish it. So please look at it whether any error is there. And you have to be unambiguous in showing the results to the outside world. Don't start publishing just because you got some results. Finally, we found his mind was correct. There was some errors there was from the background. For optical and astronomical observations, the background signal is the worst. Background signal can corrupt your signals and you will get wrong conclusions. You are very cautious about science, and don't start publishing unless you are 100% sure about it. Professor Rao was given a lot of awards. Even he was given doctorates from a number of universities. I will not read out the universities' names. And he was a fellow of a lot of academies in India, at least more than 20 academies he was a member. But some of the international awards are worth telling. He got the Group Achievement Award from NASA, USA, a Medal of Honor from the Academy of USSR, Yuri Gagarin Medal of USSR, Alan D. Email Award of International Cooperation, International Astronautical Federation, then Vikram Sarabhai Medal of COSPAR, then another greatest award from the International Academy of Astronautics, Theodore von Karmel Award. He was introduced to the Satellite Hall of Fame in Washington and Hall of Fame from IAF. Hall of Fame is the place in US and other European countries, a big museum where a place is kept for the greatest people in the world. So such a place, Professor Rao's picture was put. So he has entered the Hall of Fame in Washington. His name is there. In 2013, his name was put there. His picture is there. Karnataka government also decorated him with awards. I will not read the most of the things. If I start reading, there is plenty of things to read. But the Karnataka government gives the Karnataka awards, Karnataka Rajyotsava Award. Visvesvaraya Technical University gave the doctorate. Mangalore University, Mysore University, all those universities gave their doctorates and D.Litt degrees. And he did not only space, he had some activity with even the Reserve Bank. So Reserve Bank not making factory, how the currency notes are made. He was invited as a director of that place to give technical advice, how a foolproof currency note can be made, we cannot be tampered with, and how to make his life longer. So he gave his contributions to that. And he had a lot of other interesting contributions. He loved music. He is a lover of music. Being from Udupi, he is a lover of food. he is good in selecting food for any functions. So his mind is very good. He is good at helping people. So many of the employees and others in a difficult situation in the meeting, although he's a tough master for his work, he had a very kind mind, and all the people will vouch for his kindness and helping mind. So such a personality, we remember him when the Jawaharlal Nehru Planetarium here and the base, he was the chairman of the base governing board for almost a decade, and all the initial activities, he started the activities, later it is followed by Dr. Kiran Kumar successfully, and even this auditorium building, etc., the idea came from Professor Rao, and very particularly on the outside of this planetarium, some people wanted to have a very big flyover and a steel bridge in front of it. He vehemently objected to that. He said this place should be a nice place for studies. Students are coming here and they should be studying science. So wherever he wants to make objections, he will do objections, whether it is the government or not. But that's the type of personality we remember him. And today I urge the people, not necessarily you have to be the first rank holder in the school or high school. You put an aim, you can achieve anything you want. And as a country also, not necessarily everybody has to know how to have experience, but you put an aim for doing that thing, you can achieve it. Once you have the aim and your aims are clear, the governments will tell something, money is not there, etc., but your aim is correct, and you can convince the government and you will get the money. And India is not that poor like 60s and 70s. Now we have slightly more money available. Okay, so only thing is your imagination is only stopping you from growing further. I wish all of you to start imagining what you can do for yourself and for the country very well. Thank you very much for this opportunity. Thank you very much.
Your reflections gave us a meaningful glimpse into the past. Thank you, sir, for sharing them so graciously with us. As we are approaching the end of the program, before proceeding to the vote of thanks, I would like to make a few important announcements about the afternoon's program. So, after lunch, at 2 o'clock, there will be a talk by a Gaganyaan astronaut, followed by interactions. So, the students will get a chance to interact with the astronaut, and I'm sure all of you are excited about that. And at 3 o'clock, we'll have the competitions, the quiz finals, the pick and speak, and the paper modeling workshop. And followed by that, at 4:30 will be the valedictory session, where the winners will also get the certificates. So this is about the afternoon's program. And now I request Dr. K.V. Sriram, Director of LEOS, to propose the vote of thanks.
Good afternoon all. On the occasion of this student outreach chapter of this Aryabhatta Golden Jubilee celebration, as a committee chair, it's my great privilege to propose this vote of thanks. Professor Subramanyam, Director, Indian Institute of Astrophysics, was so kind to accept our invitation and grace this event as chief guest. A renowned astronomer and a very popular person, she gave a very informative and valuable lecture, and we extend our heartfelt gratitude to you, ma'am. Thank you. Shri A.S. Kiran Kumar sir, Member Space Commission, Chairman Base JNP, and former Chairman ISRO, readily accepted our invitation and rendered his gracious presence for this function. A simple man but a very tall figure. We are all greatly inspired by your presence here, sir, and for that wonderful speech, presidential address, what you gave here. We express our sincere gratitude from the bottom of our heart for this.
Dr. T.K. Alex, former director URSC, and our founder director Leos, Vice Chairman Base JNP, graciously accepted our invitation in a short notice and readily accepted to bring out a very detailed presentation of Professor Rao, and we are really fortunate enough to capture all the wonderful reminiscences of Professor Rao, and for some time we felt that Professor Rao is amongst us. Thank you so much, sir. Shri M. Shankaran, Director URSC, is fondly known as Live Encyclopedia of Spacecraft Technology. He is the steering force behind all our efforts. Sir, our heartfelt thanks for your continuous guidance and support, and for this very sweet address what you carried. Dr. Gurup Prasad, Director JNP, is always bubbling with enthusiasm, and he is the brain behind organizing this event at this planetarium. Sir, our heartfelt thanks for your unstinted support and captivating address. Thank you. We are going to have with us today a very special person, the astronaut designate, Mr. Angad Pratap, who is going to interact with the students and faculty in the afternoon session. So we express our sincere gratitude for his overwhelming presence for this particular event. An event of this magnitude can happen only with the presence of students and faculty who are overwhelmingly participating in this event with lots of enthusiasm. We express our sincere appreciation for all of them. Our sincere appreciation to all the staff and volunteers of Jawaharlal Nehru Planetarium for hosting this outreach program at this Professor U R Rao Bhavan. Let me also express sincere thanks to my organizing committee members of this Golden Jubilee celebration, especially the outreach committee chairman Mr. Murali and members for their meticulous efforts, and sincere appreciation for the multimedia infrastructure, documentation, outreach group MISA URSC, the transport, medical, purchase and stores, accounts, and C&MG of URSC. We are very grateful to the media team who have patiently covered this entire episode at this Jawaharlal Nehru Planetarium. Thanks a lot for everyone for being here today, and your presence makes this event more memorable. Thank you very much. Jai Hind.
Thank you, sir. I once again thank each and every one of you for being here. So now lunch will be served outside. All the students and faculty can have lunch. And from 1 o'clock, we'll be playing videos here about ISRO and different the space programs and everything. The students can come back after the lunch. From 2 o'clock, the programs will proceed. Students' lunch will be in the basement. The security can guide you there. You can go to the basement to have lunch. I request the ISRO team to come to the dais to take a group photo.
Aditya L1, India's first mission to study Sun, is expected to provide deeper understanding of coronal heating and solar wind acceleration, coupling and dynamics of the solar atmosphere, solar wind distribution and temperature anisotropy, and initiation of coronal mass ejections, flares, and near-Earth space weather. The Aditya L1 mission has various uniqueness. The mission will provide, for the first time, spatially resolved solar disk in near UV band and observe CME dynamics very close to the solar disk. The mission will have onboard intelligence to detect CMEs and solar flares and provide directional and energy anisotropy of solar wind. The Aditya L1 mission is unique in its capabilities. The mission probes the dynamics of the coronal mass ejection close to the solar disk, which provides information on the acceleration regime of the coronal mass ejection. The mission also captures the information on the energy distribution, flux, and directionality of the solar wind. This also enables getting early information on the space weather events.
Moon. This familiar object in the night sky has inspired the imagination of astronomers and ordinary people alike. From time immemorial, humans have marveled at the beauty of the moon, used it to count time and navigate the high seas. In modern times, Moon, the only natural satellite of the Earth, has acquired added importance due to the belief that Moon is the key to our understanding of the evolution of the solar system in general and Earth in particular. Besides, Moon's precious resources and low gravity have further endeared it to humans. India, a major spacefaring nation, has conducted a detailed exploration of the Moon through its Chandrayaan program. The country has sent 2 robotic spacecraft to orbit the Moon and to take a repeated look at its surface. Chandrayaan-1 demonstrated India's ability to reach the surface of the Moon at a place and time of its choice. And with it, India became the 4th country to reach the surface of the Moon in November 2008. Besides, Chandrayaan-1's conclusive discovery of water on the Moon in 2009 was praised as a path-breaking discovery. The follow-on mission, Chandrayaan-2, had an orbiter, a lander called Vikram, and a rover named Pragyan. In the past 4 years, the orbiter has repeatedly observed the lunar surface and even today is working satisfactorily. Now, 3,900 kilograms Chandrayaan-3 spacecraft is being sent to the Moon with the objective of making yet another focused attempt to slowly land on the lunar surface and to explore it with the help of a rover. Following the spacecraft launched by India's most capable rocket, LVM-3, the Chandrayaan-3 lander carrying a rover within it will be carried into an orbit around the Moon by the propulsion module. A little later, the lander will separate from that module and will attempt to make a soft landing in the south polar region of the Moon. This region is of intense interest as it has many permanently shadowed craters which could contain water ice and precious minerals. Chandrayaan-3 lander has 4 scientific instruments or payloads, of which one will study the moonquakes, while the other one studies as to how the surface of the Moon allows heat to flow through it. The third one will study the plasma environment near the moon's surface. And the fourth instrument will enable scientists to measure the distance between the Earth and Moon very accurately. The two instruments on the rover help us study the composition of the Moon's surface using X-rays and laser respectively. While the lander and rover will be in direct contact with each other. The propulsion module circling the Moon will observe the light coming from Earth, the only planet which we know which is definitely teeming with life. This observation will help in understanding the nature of distant planets circling stars other than the Sun. As Chandrayaan-3 undergoes important tests and gears up for launch, thousands of ISRO scientists, including those who will launch it, control it and receive the precious scientific information from it using giant dish antennas, are readying themselves for the challenging tasks ahead. In the past, their dedication and skill have enabled India to earn praise from across the world and made it proud. Let us wish them well in this great endeavor called Chandrayaan-3.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal. P1 tracking.
R2 tracking.
P2 tracking. Stage performance normal. P4 tracking. L1 turn stage ignited.
Plus 2 minutes.
L1 turn stage performance normal. Stages are separated. Closed loop guidance initiated.
The Aditya L1 mission carries a suite of 7 scientific payloads to carry out systematic study of the Sun. The Visible Emission Line Coronagraph (VELC) studies the solar corona and dynamics of coronal mass ejections. The Solar Ultraviolet Imaging Telescope (SUIT) payload images the solar disk in near ultraviolet and also measures the solar irradiance variations. The Aditya Solar Wind Particle Experiment, Aspects and Plasma Analyzer Package for Aditya, PAPA payloads study the solar wind and energetic ions as well as their energy distribution. The Solar Low Energy X-ray Spectrometer, SOLEXUS, and the High Energy L1 Orbiting X-ray Spectrometer, Helios, study the X-ray flares from Sun over a wide energy range. The magnetometer payload is intended to measure the interplanetary magnetic field at the L1 point. The science payloads of Aditya L1 are indigenously developed by different laboratories in the country. VELC is developed at the Indian Institute of Astrophysics, Bengaluru, Suite Instrument at Inter-University Centre for Astronomy and Astrophysics, Pune. Aspects Instrument at Physical Research Laboratory, Ahmedabad. PAPA payload at Space Physics Laboratory, Vikram Sarabhai Space Centre, Thiruvananthapuram. SOLEXUS and Helios payloads at U R Rao Satellite Centre, Bengaluru, and the magnetometer payload at the Laboratory for Electro-Optic Systems, URSC. Aditya L1, India's first mission to study Sun, is expected to provide deeper understanding of coronal heating and solar wind acceleration, coupling and dynamics of the solar atmosphere, solar wind distribution and temperature anisotropy, and initiation of coronal mass ejections, flares, and near-Earth space weather. The Aditya L1 mission has various uniqueness. The mission will provide for the first time spatially resolved solar disk in near UV band and observe CME dynamics very close to the solar disk. The mission will have onboard intelligence to detect CMEs and solar flares and provide directional and energy anisotropy of solar wind. The Aditya L1 mission is unique in its capabilities. The mission probes the dynamics of the coronal mass ejection close to the solar disk, which provides information on the acceleration regime of the coronal mass ejection. The mission also captures the information on the energy distribution, flux, and directionality of the solar wind. This also enables getting early information on the space weather events.
Moon. This familiar object in the night sky has inspired the imagination of astronomers and ordinary people alike. From time immemorial, humans have marveled at the beauty of the moon, used it to count time and navigate the high seas. In modern times, Moon, the only natural satellite of the Earth, has acquired added importance due to the belief that Moon is the key to our understanding of the evolution of the solar system in general and Earth in particular. Besides, Moon's precious resources and low gravity have further endeared it to humans. India, a major spacefaring nation, has conducted a detailed exploration of the Moon through its Chandrayaan program. The country has sent 2 robotic spacecraft to orbit the Moon and to take a repeated look at its surface. Chandrayaan-1 demonstrated India's ability to reach the surface of the Moon at a place and time of its choice. And with it, India became the 4th country to reach the surface of the Moon in November 2008. Besides, Chandrayaan-1's conclusive discovery of water on the Moon in 2009 was praised as a path-breaking discovery. The follow-on mission, Chandrayaan-2, had an orbiter, a lander called Vikram, and a rover named Pragyan. In the past 4 years, the orbiter has repeatedly observed the lunar surface and even today is working satisfactorily. Now, 3,900 kilograms Chandrayaan-3 spacecraft is being sent to the Moon with the objective of making yet another focused attempt to slowly land on the lunar surface and to explore it with the help of a rover. Following the spacecraft launched by India's most capable rocket, LVM-3, the Chandrayaan-3 lander carrying a rover within it will be carried into an orbit around the Moon by the propulsion module. A little later, the lander will separate from that module and will attempt to make a soft landing in the south polar region of the Moon. This region is of intense interest as it has many permanently shadowed craters which could contain water ice and precious minerals. Chandrayaan-3 lander has 4 scientific instruments or payloads, of which one will study the moonquakes, while the other one studies as to how the surface of the Moon allows heat to flow through it. The third one will study the plasma environment near the Moon's surface. And the 4th instrument will enable scientists to measure the distance between the Earth and Moon very accurately. The 2 instruments on the rover help us study the composition of the Moon's surface using X-rays and laser respectively. While the lander and rover will be in direct contact with each other. The propulsion module circling the moon will observe the light coming from Earth, the only planet which we know which is definitely teeming with life. This observation will help in understanding the nature of distant planets circling stars other than the Sun. As Chandrayaan-3 undergoes important tests and gears up for launch, thousands of ISRO scientists, including those who will launch it, control it and receive the precious scientific information from it using giant dish antennas, are readying themselves for the challenging tasks ahead. In the past, their dedication and skill have enabled India to earn praise from across the world and made it proud. Let us wish them well in this great endeavor called Chandrayaan-3.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal. P1 tracking.
R2 tracking.
P2 tracking. Stage performance normal.
P4 tracking.
L1 turn stage ignited.
Plus 2 minutes.
L1 turn stage performance normal. Stages are separated. Closed loop guidance initiated.
The Aditya L1 mission carries a suite of 7 scientific payloads to carry out systematic study of the Sun. The Visible Emission Line Coronagraph (VELC) studies the solar corona and dynamics of coronal mass ejections. The Solar Ultraviolet Imaging Telescope (SUIT) payload images the solar disk in near ultraviolet and also measures the solar irradiance variations. The Aditya Solar Wind Particle Experiment, Aspects and Plasma Analyzer Package for Aditya, PAPA payloads study the solar wind and energetic ions as well as their energy distribution. The Solar Low Energy X-ray Spectrometer, SOLEXUS, and the High Energy L1 Orbiting X-ray Spectrometer, Helios, study the X-ray flares from Sun over a wide energy range. The magnetometer payload is intended to measure the interplanetary magnetic field at the L1 point. The science payloads of Aditya L1 are indigenously developed by different laboratories in the country. VELC is developed at the Indian Institute of Astrophysics, Bengaluru, Suite Instrument at Inter-University Centre for Astronomy and Astrophysics, Pune. Aspects Instrument at Physical Research Laboratory, Ahmedabad. PAPA payload at Space Physics Laboratory, Vikram Sarabhai Space Centre, Thiruvananthapuram. SOLEXUS and Helios payloads at U R Rao Satellite Centre, Bengaluru, and the magnetometer payload at the Laboratory for Electro-Optic Systems, URSC. Aditya L1, India's first mission to study Sun, is expected to provide deeper understanding of coronal heating and solar wind acceleration, coupling and dynamics of the solar atmosphere, solar wind distribution and temperature anisotropy, and initiation of coronal mass ejections, flares, and near-Earth space weather. The Aditya L1 mission has various uniqueness. The mission will provide for the first time spatially resolved solar disk in near UV band and observe CME dynamics very close to the solar disk. The mission will have onboard intelligence to detect CMEs and solar flares and provide directional and energy anisotropy of solar wind. The Aditya L1 mission is unique in its capabilities. The mission probes the dynamics of the coronal mass ejection close to the solar disk, which provides information on the acceleration regime of the coronal mass ejection. The mission also captures the information on the energy distribution, flux, and directionality of the solar wind. This also enables getting early information on the space weather events.
Moon. This familiar object in the night sky has inspired the imagination of astronomers and ordinary people alike. From time immemorial, humans have marveled at the beauty of the moon, used it to count time and navigate the high seas. In modern times, Moon, the only natural satellite of the Earth, has acquired added importance due to the belief that Moon is the key to our understanding of the evolution of the solar system in general and Earth in particular. Besides, Moon's precious resources and low gravity have further endeared it to humans. India, a major spacefaring nation, has conducted a detailed exploration of the Moon through its Chandrayaan program. The country has sent 2 robotic spacecraft to orbit the Moon and to take a repeated look at its surface. Chandrayaan-1 demonstrated India's ability to reach the surface of the Moon at a place and time of its choice. And with it, India became the 4th country to reach the surface of the Moon in November 2008. Besides, Chandrayaan-1's conclusive discovery of water on the Moon in 2009 was praised as a path-breaking discovery. The follow-on mission, Chandrayaan-2, had an orbiter, a lander called Vikram, and a rover named Pragyan. In the past 4 years, the orbiter has repeatedly observed the lunar surface and even today is working satisfactorily. Now, 3,900 kilograms Chandrayaan-3 spacecraft is being sent to the Moon with the objective of making yet another focused attempt to slowly land on the lunar surface and to explore it with the help of a rover. Following the spacecraft launched by India's most capable rocket LVM-3, the Chandrayaan-3 lander carrying a rover within it will be carried into an orbit around the Moon by the propulsion module. A little later, the lander will separate from that module and will attempt to make a soft landing in the south polar region of the Moon. This region is of intense interest as it has many permanently shadowed craters which could contain water ice and precious minerals. Chandrayaan-3 lander has 4 scientific instruments or payloads, of which one will study the moonquakes, while the other one studies as to how the surface of the Moon allows heat to flow through it. The third one will study the plasma environment near the Moon's surface. And the 4th instrument will enable scientists to measure the distance between the Earth and Moon very accurately. The 2 instruments on the rover help us study the composition of the Moon's surface using X-rays and laser respectively. While the lander and rover will be in direct contact with each other. The propulsion module circling the moon will observe the light coming from Earth, the only planet which we know which is definitely teeming with life. This observation will help in understanding the nature of distant planets circling stars other than the Sun. As Chandrayaan-3 undergoes important tests and gears up for launch, thousands of ISRO scientists, including those who will launch it, control it and receive the precious scientific information from it using giant dish antennas, are readying themselves for the challenging tasks ahead. In the past, their dedication and skill have enabled India to earn praise from across the world and made it proud. Let us wish them well in this great endeavor called Chandrayaan-3.
10, 9, 8, 7.
Aditya L1, India's first mission to study Sun, is expected to provide deeper understanding of coronal heating and solar wind acceleration, coupling and dynamics of the solar atmosphere, solar wind distribution and temperature anisotropy, and initiation of coronal mass ejections, flares, and near-Earth space weather. The Aditya L1 mission has various uniqueness. The mission will provide for the first time spatially resolved solar disk in near UV band and observe CME dynamics very close to the solar disk. The mission will have onboard intelligence to detect CMEs and solar flares and provide directional and energy anisotropy of solar wind. The Aditya L1 mission is unique in its capabilities. The mission probes the dynamics of the coronal mass ejection close to the solar disk, which provides information on the acceleration regime of the coronal mass ejection. The mission also captures the information on the energy distribution, flux, and directionality of the solar wind. This also enables getting early information on the space weather events.
The breathtaking view of the night sky. For centuries, humans have desired to ascend the starry skies and to explore the worlds in that heavenly abode. Notwithstanding that desire, the ability to travel to space was acquired by humans only 7 decades back. Today, India is one of the few countries with the ability to build and to launch artificial Earth satellites and robotic spacecraft to space. India's first
Indian astronaut, one of the 4 selected Indian astronauts of Gaganyaan? Okay, before that, let me read about him, in fact, how great he is. What are all his achievements? Today, we have with us, okay, he is going to come. We have Group Captain Angad Pratap, okay, one of the 4 astronaut candidates selected for Gaganyaan program. Okay, let me enlighten you on what are all his achievements. Okay, Group Captain Angad Pratap joined National Defence Academy in December 2000 and got commissioned as a fighter pilot in December 2004. In his operational career, Shri Angad Pratap has flown the MiG-21, one of the finest aircraft, and Sukhoi 30. You would have seen the aerobatics of that over Aero India. And he is a flying instructor and an experimental test pilot. In December 2017, he was part of the first launch of the BrahMos air version missile from Sukhoi aircraft. And in January 2019, he himself test-fired India's first anti-radiation missile, the Rudram-1, from a Sukhoi aircraft. Look at his great achievements. In January 2020, he got selected for India's first astronaut corps. In 2021, he successfully trained at the prestigious Yuri Gagarin Cosmonaut Training Center, Moscow, on the Soyuz spacecraft and the Russian segment of the International Space Station. Upon return to India, he has completed training on the Gaganyaan spacecraft. You know that it is our own endeavor. He was awarded the prestigious Space Wings by the Honorable Prime Minister of India, Shri Narendra Modi, on 27th February 2024. Group Captain Angad Pratap has a total of 2,300 hours, 2,300 hours across 18 different types of aircraft he has flown. Okay. They include fighter and transport aircraft. Wait, still fantastic achievements are there. Group Captain Angad Pratap is an Iron Man. What does it mean? Having completed the full Ironman Triathlon 2023 at Subic Bay, Philippines, completing a continuous 4-kilometer swim, in the ocean, followed by a 180-kilometer cycle, followed by a 42-kilometer marathon run. Unbelievable, isn't it? He is a trained skydiver, a certified scuba diver, a certified mountaineer, and has completed a 100-kilometer ultra marathon and has a 7 non-stop swim to his credit. Group Captain Angad is presently pursuing an M.Tech from Indian Institute of Science, Bangalore. Now, are you ready? Let us welcome with a thundering applause Group Captain Angad Pratap. Yeah. Give a standing ovation. Welcome, sir. Welcome to you. I'm sure that this is the most awaited session today. Please, sir, please. Thanks, Group Captain. Please. Thanks for gracing the occasion. And yes, we'll start the program. And I'm sure and I'm very happy he is accompanied by his son. Yeah, kindly stand up. Yeah, wave at them. Wave at them there, that side. So nice, so nice. Like father, like son. You see, the way in which he has maintained his physique. That is the way we all should be. Getting selected as an astronaut is not, first of all, getting selected for the Indian Air Force is not easy. Getting selected to become a fighter, the test pilot is still difficult. And getting selected as an astronaut is much more difficult. Okay? Now, I would request Shri Angad Pratap to say a few words first, or if he speaks on the subject of his which is his passion, or today's talk. Afterwards, we will take up the Q&A, that is interaction. And sir, the stage is yours, please.
Check. Okay, very good afternoon to all the distinguished people we have here today. First of all, I would like to thank all the organizing committee people from the Indian Space Research Organization to have given me this opportunity and the invitation which has been extended. Also, I would like to give my sort of welcome greetings to all the children who are here. They are looking very enthusiastic about the interaction. And of course, all the accompanying teachers who are here along with them. So I think we have about an hour for this interaction. And the way I plan to go about it is, I have a short presentation here. I don't know what are your expectations from me, but what I have to give today is what I will. So towards that, I have a structured presentation in the beginning, which will kind of set things in motion. And subsequently, we can have the interaction in which people who want to ask certain questions can do that. Before I go ahead with today's talk, let us realize that, okay, there's a lot of, I would say, flamboyancy about being an astronaut, a fighter pilot, a lot of showbiz, patches and everything. It's an opportunity which very few people get, and you should utilize that opportunity with a lot of maturity and responsibility. That is the first thing I would say. And I would say that I'm one amongst the many people who've got such an opportunity. And when I am going to talk today and interact with all of you, it is not going to be about me, but about what I would be talking. I would be only utilizing myself as a launch pad or an instrument to convey my thought processes and all the knowledge and learning that I have gained over the past, I would say, 2 decades of my life, of my sensible life, I would say. So the important part during the entire interaction would be not to glorify the concept of astronaut or Group Captain Angad Pratap, but concentrate on the message that I'm talking about here. Okay, it's always good to be thrilled with the uniform, with all the showbiz around this business of astronautics. But you need to stay calm, keep your head where it should be, and take home the right message is the first thing that I would say. With that, I think we can start the presentation. Okay. Yeah. Okay. Yeah. So if I would define my life in the first instance, these very beautiful words from one of the great authors. It's Robert Frost. This is something which defines my life. Okay, that in my life always there were two roads which were diverging in a wood, and I have always taken the one which is less traveled by, and that has essentially made all the difference. And in almost all probability, most of us, what we do is we end up taking the road which everyone else is taking. And if you take that road, you're choosing the comfortable option out of the two options that life will always present. So I would say that I was a little, probably something wrong in my head, that I continue to take the wrong road always. But, and people kept telling me, don't go there. And while walking on that road, I have reached here today. So you can understand what I'm talking about. Okay, next please. Okay, these are some really nice quotes that I will utilize to spread across a few messages. So the first part of my presentation is going to be talking about a lot of quotes and mostly about, life lessons. And the second part will be about, in a way motivating the kids who are here. So working out will make you feel weak when it's actually making you stronger. So for example, if I say that, oh, I'm not able to do push-ups, and I decide I want to do 80 push-ups, that's my target. And I'll go to the gym and I'll start working out and I'll see, oh my God, I'm just able to do 5. What is this? So when you will start working out towards the target in life, be it mathematics, be it physics, be it learning a new language, programming, you will straight away start realizing how weak you are. And that can get a bit demotivating to begin with. But always remember, it will always be like that. Whatever journey that you want to go towards, let's say you want to run a half marathon, 21 kilometers, you'll start running, you'll check your watch after 5 minutes, you'll say, oh, I've just run 1 kilometer, 20 more to go. It's the thought process here that makes all the difference. And you should already be aware that this will happen. The first day you will go, you'll hit 5 push-ups, the next day 7, 8, leave a gap, 10 days, go later, you'll start doing 12. Soon that number will become double up to 25. And one day you will reach eventually where you want to. So learning new things will actually make you don't know anything and you're a dumb guy. When it's actually making you smarter. So you fill up your glass drop by drop is what I'm probably hinting at. And the same feeling you'll get. Investing in yourself will make you feel broke. You'll start keeping some amount of money for investing. You'll start living your life in a more restricted way, right? And you'll feel, oh, actually I don't have money. But it's the other way around. Actually you're trying to grow. When you try to grow, you actually keep feeling weak till such time you've attained that point from where you start feeling strong. Okay, next please. Okay, this is a video which is depicting about very common thing that we talk about, that you have to cross various barriers before you reach your goal ultimately. So first thing will be the comfort zone. You'll say, oh, I can only do 5. Oh, and the 8th one is so difficult. Oh, I'll leave it here only. So this should be self-explanatory in a way. Can we please play the video? So there are so many zones. So you'll have your comfort zone, then you'll have some other zone, then you'll have some learning zone where you'll start learning. Once you've learnt, now because you have learnt something, there's further struggle with that knowledge. And once you have struggled with that knowledge enough, you'll reach another paradigm. Next. Okay, this is a very nice quote. Okay, it says the man who loves walking will go further than the man who loves the destination. There's something similar to what I started talking with the word go, which I said that, okay, this jacket here, the astronaut tag, fighter pilot, scientist, okay, a software engineer, these are targets. But achieving those targets cannot be the sole aim in life. Life is more about how you live from today till the point you achieve those targets. Each day it matters. And we say this, that you should not, you should work without thinking about the consequences of the output your work will produce to a certain extent. So you have to be, in a way, work. You don't get results, you still work, is what I'm probably trying to hint at. Next. Okay, can we just have the front lights switched off a bit so that this video is more clearly visible? Because the people in the video may not be visible. Few of the lights, can we have them off, or is it, if it's logistically a challenge, we can? Yeah. Now we can please play this video. Thank you.
By rewards. Stop being driven by outcomes. Stop being driven by, if I get this, I'm gonna do this. Just work. And if you don't get what you thought you were gonna get, show up and still go to work. Because along the process, what's more important, what you acquire or who you become? And a lot of people think what they acquire is the thing that makes them who they are. No, it's who you become in the process of chasing what you want to acquire.
So I hope I'm making myself clear here. It is not becoming that end state that you desire to become, but in the process of achieving that, what you've become in the journey, that modified person, that is the main target. You may not achieve that particular target in that point of time, but what you have become in the process of achieving that will take you to some different path, and you'll probably end up becoming something else, but you will reach where you're destined to, and if you're a positively thinking person, you will reach nice places. Next. Okay, this is a message specifically for the children. Okay, I've seen most of the children of the current generation, and I'm not a guy who draws differences between the generations. Any which ways, the next generation always outsmarts the previous one. So, but a lot of the current generation children carry a kind of a misnomer that for everything we should have a shortcut in life. There is never a shortcut to hard work in life. What can be produced by certain quantum of hard work will only be produced by that amount of hard work only. It's a law of physics. So you have to think about it. There are no shortcuts in life. There are no free lunches. Okay, can we play this video, please?
To get anything of value, you have to sacrifice. Do you know that the harder thing to do and the right thing to do are usually the same thing? Nothing that has meaning is easy. Easy doesn't enter into grown-up life.
Nothing that has meaning is easy, and easy doesn't grow up into elder life, is one message that I would want to convey to the children who are here, and I feel that the children are grown up enough, most of them, who will be able to understand. Yeah, next please. So discipline is not about perfection, discipline is about continuity. You will fail on a regular basis. Every day, just because you've chosen your target to become an astronaut, go to the moon, become a top scientist of the country, an engineer, a doctor, top level, everything. That doesn't make you that today. And you'll start making mistakes and say, oh, I'm just making these mistakes. How can I even become that? It is not like that. The right one is the realistic model. The left one is a fictional model. There's nobody who is like that. Not me, not anyone. So we must remember that when we are going on a journey, we should be prepared to fail on a regular basis, get up and start walking again. Next, please. No one can be 100% every day. It's the same message that I talked about. And that's okay. And you just move. You don't have to be 100% every day. Next. Okay, be the person who still tries after failure, after frustration, after disappointment, after exhaustion, heartache. Be the person who musters up the courage to believe that a new attempt can still manifest a new outcome. And it will. It has happened to me at least, 15 to 20 times in my life. So be the person who still tries. Next. These are some normal quotes that for the sake of or the paucity of time I would just read and not probably explain. We cannot become what we want by remaining what we are. We have to change to see the change that we want to be. Next. You can see this tree. I hope it's not getting hidden by the chairs here. The tree obviously fell a long time ago, but it never saw the fall as the end of its existence. Simply accepted its new posture and found new avenues for growth, adaptation. It's the way of nature, and we are part of the nature too. We are this planet. I don't know how many of you do realize that life and the planet are not separate things. It's a living planet, and we are a representation of this planet. Next, please. I really like this one. A man is great not because he hasn't failed. A man is great because failure hasn't stopped him. You will fail, you will keep failing, keep failing, keep failing. People will tag you like a loser, like a failure, and suddenly you will come out because you never gave up. Next, please. If you want to feel better, blame others. If you want to get better, just improve yourself. Your competition is always with your own self. Next. Okay, now I would like to quote a life example from my marathon career. This is a 75 kilometers marathon I ran in 2023 August, and I achieved second position in this. You can see the other two guys are quite young. I'm a 40 plus guy here, and still I managed to come in second position. And so can you please go to the next one? So I completed the previous one in something like 9 hours 45 minutes. And this one is a 100 kilometers marathon I ran the next year in 2024, that is last year in March. And I barely managed to finish this one. I was supposed to finish this in 13 hours and I ended up finishing it in I think 17:53. That's almost 18 hours or 4 hours late. Now if I was to always cherish one of the two runs in my life, for a normal person, which one would it be? The first one. But which one do you think is a failure? The second one, right? Intuitively speaking, it is the second one. However, I really cherish this run more than the previous run. I don't even think about that run, but I think more about this run. Why? Because in this particular run, I was running in second position even in this run till about 15th kilometer, and at around 15th kilometer I had a full body breakdown and full body ache and everything, and I was like completely out of my normal self. And I tried to linger on, pushed from 15th to the 35th kilometer. In between that time I thought of calling the ambulance and stopping the run. But something kept me going, and at the end of the 35th kilometer, I was back and I started running again, and I managed to finish this with, everyone went past me. That also can be demotivating, right? But I still ran, again overtook a lot of guys, and still ended up completing the thing. So there were so many lessons that I learned in this particular one. In the first one or the previous one, I was just running second position throughout and finished. There was no learning there. But here, I came to know many more things about my body, how it behaves, what I need to do, what are the right kind of shoes I should wear, what are the correct intervals at which I should really be taking electrolytes, what are the other things that I didn't know about ultra marathon running. This run was probably the biggest teacher for me in my ultra running career. So I would always remember this. It may look like a failure, but it is the failures from which we learn more than the successes. That's why this is a treasure trove and the previous one is not. I had a very easy time in the previous one. But in this one, I understood my body better. I understood the dynamics of how human body behaves when you run very long distances. And what are the things, what are the correct do's and don'ts. Okay, yeah, next please. So every failure is a lesson. If you're not willing to fail, you're not ready to succeed. A lot of times we don't try because we know, oh, ye to I will not be able to do. I will fail for sure. So that should not be working as a barrier or an impediment. Okay. Yeah, this is just another one. I ran 2 weeks ago or 3 weeks, I think 23rd of March. Again came in 6th position, overall 9th position. In my age category I was 6th, top 10%. Still able to maintain my running performance and I'm very happy about it. And this is possible again only purely because of being positive. So it is very, very important to keep trying, keep believing in yourselves. Next. So I talked about, and the same quote has come. So this is a very nice quote I like from the cricketing brand called SG. In order to become something, first of all, you need to believe in yourselves. And for that, you need to break through the current shackles which the society or the people who you are in contact with put on you. They'll say, oh, this boy is weak in mathematics, you know, he's always been like that. He's a loser. Oh, you are a 60% grader. Oh, you are an average guy in the class. There's nothing like that. Until unless you tag it on your own forehead and say, yes, this is who is me. You need to break yourselves from those shackles. Think, what is it that you're doing is not really striking it rich for you? Start taking a different path. Start working hard and start working towards what you want to be. If you think that by just sitting in a chair, things will happen automatically and start scoring good in your exams, or for example, start performing good in the field games during the physical training periods or in the evenings when you play, it just won't happen on its own. Next. Okay, most of us are in the habit of cribbing a lot. I've also done it. So I'm no different than you people. I'm some Superman standing here today and I've got the powers that, oh, now I will teach all of you something. No. There are a lot of people, in fact, amongst in the front row here who have got different life experiences, probably better than mine, and they are not sharing those today. That's all. A lot of us crib in our lives. I have also done it, wherein we start giving excuses for the things we are not able to do. He came first in that thing. Oh, because he has done that. I was not able to do because my father, because my mother, because my teacher, because my brother, because I was born in this family. No, because I'm in India. We'll keep cursing something or the other rather than working on the thing that we are really wanting to or others are talking about. And here is a Paralympic athlete. She doesn't have both of her hands. Her name, Shanta Devi, I think, from Kishtwar. Sheetala Devi. So, she's the best example of not cribbing. I mean, we are perfectly, I believe nobody is a Paralympic or para-athlete kind of a person here, hopefully. We are all complete in ourselves. There's nothing which is less in us. If people like her can set examples for people like us, then what are the kind of examples and potential that we have? We need to really, think it over. Yeah. Can you please play this?
सच में किसी में कोई कमी नहीं होती.
Yeah, next. So with that, I have come to the end of the first part, in which I was talking a lot about quotes and life lessons. Now I would like to this is the motivation part, wherein there will be a lot of glam and things related to flying and astronaut and everything that I would like to portray, so that the children here, they get positive motivation of what they can be if they work in the correct direction. In fact, today's interaction is all about all the children who are present here. You are small energy centers, and the aim of all the organizers and self is you are the future of the country, and we want to channelize all of your energies in the correct direction. So towards that, we would like to motivate you by showing you certain clips and photographs, and I hope you do get motivated. So this is a video from the zero gravity parabolic flight training that I underwent in Russia. Yeah. Just wearing a spacesuit. The microgravity episode each is approximately 28 seconds. You can see there's a person who's holding me, he's my instructor. Otherwise, if he doesn't hold me, I'll go to the top of the aircraft. And now, as soon as the episode ended, I've come back. Okay. Yeah, next one please. I have another video in which now I'm going to, so that was called the spacesuit donning, and this will be the spacesuit doffing. Yeah. Look at the way I mean like continuously going up towards the roof of the aircraft. And the gravity has resumed. And you can see I'm chewing a bubble gum there. It's not for style. If you keep chewing a bubble gum while doing the zero gravity, the probability of you throwing up or nausea building up is, it sort of reduces a bit. So that is why that is there. Otherwise, yeah. Next, please. Okay, so I am an Ironman. I completed the Philippines Ironman 2023. It is something which I was trying to do for the past 8 years prior to 2023. I failed to complete a 3/4 version of the same event in 2015. And that I was living with that failure. I won't call it a failure. I will say I was living with that partial success in which I couldn't complete the last 13 kilometers for 8 years. And finally in 2023, I managed to complete this. Yeah. I am a skydiver. I think in my biodata, which was read before I walked into the auditorium, it was sufficiently this thing. This is a tandem one which I've done, I think somewhere in 2015. And apart from this, in the military, I have undergone a formal skydiving training in which I have the requisite number of jumps. Next, please. Yeah, I'm also a scuba diver, level 4 scuba diver, and I intend to complete my dive master training by next year sometime. Next. Okay, I'm also a mountaineer, and the peak that you see in the center, it's Mount BC Roy, 18,000 feet. I climbed it at exactly the time which is indicated there at 10:34 AM on 10th of November. I've done a lot of crazy adventure sports in my life, but there's something which never comes closer to challenges and difficulty. It's mountaineering. It's unarguably the toughest adventure sports in the world. Next, please. Of course, I'm a fighter pilot. Yeah. And a pioneer astronaut for my country, of course. Yeah. I hope these pics. Can you please go back to the previous slide? So yeah, this is on the backdrop which you see is the Gaganyaan simulator, and because we are test pilots, we are closely working with the Indian Space Research Organization for the development of the simulator itself, the way the things will be positioned, how should be the controls, what all should be indicated in the display inside, making all the procedures and everything. Yeah, so it's a rare opportunity which only pioneer astronauts get. Probably when you guys will grow up and 10 to 15 years from now, you will come into the Indian space program as an astronaut. You may not get similar opportunities, but you'll get opportunities of a different kind. Probably you'll have the Indian space station already flying up there, and you will just come into the program and you will be able to hop into the Indian Bharatiya Antariksh station, which is going to be a different experience altogether. Yeah. Next. This is again from the zero-G training, the Gaganyaan simulator, and the third picture is the one about that is the Soyuz simulator in Russia, on which I have trained for almost 40 hours or 40 sessions, I would say, because each session can extend up to 2 to 4 hours. And in the end, you have the human-rated launch vehicle of the Indian Space Research Organization, which will take the Gaganyaan into space. So this is the Gaganyaan crew module. Below the crew module, there is a second module which is called the service module. Together, the service module and the crew module are called the orbital module, and they are ramped up inside that place on the top portion of the rocket. It piggybacks there and is taken to space. In almost all probability, in this year, we will see sort of dry run of the actual mission in the form of the G1 mission. Yeah. Next, please. Yeah. So now we can have the Q&A session of interaction. Yeah. Yeah.
Thank you very much, sir, for your enlightening talk. You are a fighter pilot, you are a test pilot, you are a pioneering astronaut, and you are an Iron Man. But I didn't know that you were a philosopher also. It was such a nice thing for you to speak about, Group Captain Angad Pratap is so, I would say, very simple. And he said, fighter pilot, astronaut, scientist, all this, not only the glamour associated with it, with lots and lots of effort, perseverance, dedication, only you can go to that state. So that is what children of today, they need to know. Thank you, sir, once again. And on behalf of U R Rao Satellite Center and JNP, and on my own behalf, we would like to present you a small memento and a sapling, please. Yeah. Now, now the stage is open for Q&A, and where is the mic? Oh, no, not for sir, for you. Yeah, mic is. Okay. Who will ask the first question? Just raise your hand. Yes, that girl. Wait. I'll come to you. Yeah, you can give her. Quickly, you have to ask, please.
Good afternoon, sir. It's very pleasant to meet such a great and a legendary astronaut from face to face. I have this one question which I would like to ask about the Gaganyaan training program. Like, how was your experience in the Gaganyaan training program?
May I know your name first of all?
My name is V.S. Nisita, sir.
Okay, and you're in which class?
Ninth. I'm in grade 9.
Okay. Whenever you're asking a question, I would request to just tell the name and the class. Okay. So it's a very nice question that you ask. I think most of the details for the Gaganyaan training are very much there in the media. So you're saying what was my experience? How was my experience of the Gaganyaan training? Okay. So I was initially trained as an astronaut in Russia for almost 1.5 years. And after that, I have trained in India as well. In India, for example, right now, all of us, like I brought out that we are pioneer astronauts. As an organization, the Indian Space Research Organization is also venturing into human space flight for the first time. And as far as the training part is concerned, it has been fabulous. The Indian Space Research Organization has been supporting all the 4 astronauts in a very, very nice way. As part of our training, we have had our academic schedule, wherein we have got the academic component of classes being undertaken by professors from the Indian Institute of Science. So you can imagine it's the best in the country that is available, that has been offered to us. We also have physical training sessions almost on a daily basis. but primarily at least 3 times in a week we need to have, and each of the physical training sessions continues for almost 2 to 2.5 hours. Apart from the basic core academic sessions and the physical training, we also have aeromedical training in which we undergo centrifuge runs. We have a aeromedical simulator which simulates various kind of circular motions to induce nausea. We have the hyperbaric chamber. So that is one. Apart from that, the astronauts also undergo a very heavy dose of psychological training. It sort of starts withering away. So all these things that I talked about, when you enter into the astronaut training, they are very intense. But as the training program continues to progress further, things start to become easy. But all of us certainly need to understand one thing. As of now, with the kind of resources and the methods that we have available for going to space, we really can't send everyone. So a person, if he wants to become an astronaut, especially a professional astronaut, you need to prove yourself in multiple fields. You need to be very good in academics. You need to be very good in your physical training performance or outdoors as well. And your psychology needs to be there, right? So for now, that's a restriction. But we never know, 1.5 to 2 decades from now, this training and all may not be this difficult, and space will be more accessible for more number of people, and people will be able to become astronauts in a much more less rigorous way. Yeah.
Next one. Yeah, that boy there. Yes, blue color shirt. Please mention your name. Yes, your name as well as the class in which you are studying. Please.
Good afternoon, sir. My name is Pranav. I'm from grade 9. Sir, so as you like adventure sports very much, if you are not an Air Force officer, what adventure sport would you pursue a professional career in?
Okay, that's a very nice question. So like I said, mountaineering is one challenging sport that I liked a lot, and if I was not in Air Force and I had only adventure sports as an option, probably I would have been doing mountaineering. Yes.
Thank you so much, sir.
Yeah, that girl there first. Yeah. I'll come to you next to that spectacled one. Yeah.
My name is Anvita. I'm in 8th grade. My question is, what inspired you to become an astronaut?
Okay, you can sit down. Yeah, after you ask the question, please don't keep standing. Yeah. So what inspired me to become an astronaut? Yeah, certainly to begin with, I would not deny that getting that opportunity in the far future, when I actually get ultimately designated to go to space and I do get to taste space flight, the first and foremost thing is the opportunity to see our little blue planet from the space. And they always say this, that once you go to space, you actually realize there's a disconnection phenomena, and look at the other part of the universe and you say that how small we are, and we are unnecessarily creating a lot of problems for ourselves when we live here on Earth. So, of course, that view and the thought processes that thing will generate has been a big motivating factor. But apart from that, when I think more pragmatically, of course, the life of an astronaut is really something which not all of us get an opportunity to live, wherein you can continue to develop yourself academically, in the physical domain, and a lot of other things. Okay, so for example, this interaction with me that you people are having, probably you may not realize this, that whenever I go for such kind of interactions, I end up doing something like 2 in a month, and I learn back a lot of things. So I'm not here only to, share my experiences. The kind of questions people ask, it's a kind of a big addition in my own learning curve. So this is a very rare opportunity wherein your health is being looked after by your organization. Your psychology is continuously being nudged towards what it should be. Your medicals, you're physically trained regularly. You regularly get to travel to different places within India and abroad. You get opportunities on various platforms, and you can write books if you want on technical topics. So there are technical engagements. There are engagements like the one which we are having today, in which I'm talking more about life lessons and motivation. There are technical sessions. Then there are other sessions in which I will talk specifics of space missions, space systems, or things like how to become an astronaut and things like that.
Yes, that boy who is holding the microphone. Next, it goes there to that girl on that side. Yeah, black shirt. Yes. Yeah, now you kindly ask. Yeah.
Namaste, sir. My name is Sriyadatta Karthikeya of Class 8 KVIAC. Sir, I'm really inspired by your journey. Sir, in your previous answers, I had heard that you had mentioned something about psychological training. So, sir, how do you manage to stay so humble regardless of these many significant achievements and not gloat up?
That's a very nice question that you've asked, and I won't deny that I did not gloat up. There was a time that I also used to feel that anti-gravity effect and gloat up. And I used to find it hard to come back. But honestly, it's all about honesty, okay? So we all know what kind of talent and people we have in our country, right? So when I look at talent and the kind of brains we have in the country, there are enough number of people who can replace me here. So it's all about opportunities, right? That you got the opportunity and somebody else did not. And that is not only true for me, it's a lot true about a lot of other people who wanted to become a pilot, who wanted to become a doctor or an engineer or a scientist. So apart from the hard work, there are things which are beyond your control which have to really work right. And when that is the case, wherein you know that, oh, I am not some privileged soul who was only born to do this, but there are others who could have been here, but only I am here, then where is the false bravado about it, right? Yeah.
Yes, next that girl. No, there. Yeah, she's the one. Yes. No, not that one. In front of her, that black colored, shirt. Yes, that girl. Yeah, please go ahead.
Hello, my name is Yash and I'm in 6th grade. Sir, I have one question for you. How are you mentally preparing your mind for the challenge ahead, like going to space?
Yeah, that is also a very good question. Okay, as a military person, fear is something which is not there in your dictionary to begin with. Okay. But yes, still there are times when I actually think about the mission, that if I was actually going tomorrow, what are the kind of thought processes which will come to my mind. I have, as a test pilot, taken various aircraft to their limits of all sorts, flown very, very low, flown very high speed, going supersonic almost daily, 2 or 3 times in a day, and pulling a lot of Gs, 8, 9 Gs and things like that. But this is a different kind of a mission, and I think closer to the mission is the time when the brain will really start thinking about those things. I've not really thought about it, but we have to understand that when me or anyone else who gets to undertake this mission, the first mission for Gaganyaan, the second mission for Gaganyaan, any of those missions, it's a big opportunity to sort of take that ride for the cause of science. Okay, I am actually nothing but a product of science who's sitting here, and for the cause of science, even if there was a lot of risk involved, I will not think twice and I will just sign up and say, okay, I'm in and I will go. So that's what it's about. So you don't think about the fear factor, and you think about the higher cause, and there's nothing else which will come into your way, and you don't really bother a lot. It takes just about 15 minutes to go to space, and it takes a little longer to come back, something like 25 minutes. So it's okay. I mean, we've been sitting here for last 45 minutes already.
Kindly give that, those 5 girls who are sitting there. One of them, she raised the hand. Yeah. No, not there. I'll go to her later. Yeah, here. No. What? Sorry.
Good afternoon, sir. My name is Rachita. I am studying in 9th standard. May I know your secret of fitness? Is it your willpower or the nutrition you are getting?
Okay, that is a very nice question, but you look very fit yourselves also. Okay. The secret of my fitness is primarily because I have been relentlessly working on it for almost a decade and a half now. Even though before I came into the program, I used to run Ironman events, and I used to do a lot of cycling, a lot of swimming, running and things like that. And wherever something crazy is going on, you will find Angad Pratap there. So yes, I invest a lot of time into doing research about nutrition. So for example, I'm a person who's of the firm belief for the last 10 years that it is nutrition which is more important than the physical training part. So towards that, somewhere in 2018 is the time I was any which ways a very not a very clear-cut non-vegetarian. In 2018, I became a pure vegetarian, and that has sort of helped me a lot in maintaining myself. And off late, in the last 1 year, after doing a lot of research, and this is only about me, I'm not trying to make everyone vegetarian here at all. I'm not trying to impose anything. So I found out a lot of documentaries online and a lot of things which have proven to me without doubt that for maintaining your health, you need to, if you are into high performance sports, you certainly need to be a vegetarian to begin with. But if you end up giving up on milk as well, it will further sort of improve your performance to next level. So for last 6 months, 7 months, I have turned vegan, and that has also sort of improved my performance. One of the photographs in which I talked about coming in the top 10% in the OT marathon, which is a very prestigious and difficult event. I attribute a lot of my success to me being a vegan. So me being a vegan and constantly engaging myself into endurance sports is probably the secret to my health. I am also very strict with my diet. I am very particular about how much I eat, what time of the day I eat, and what I eat, what before, what after. I eat a lot of salads, okay? For example, I am a person who takes mostly sattvic food to the maximum extent possible. Yeah. That's it.
Yes, that's it.
Good afternoon, sir. Myself, Meher Fatima from 10th grade. I want to ask, what were your feelings when you saw Earth from space for the first time?
Yeah, I have seen Earth from space just like you on the video till now. I'm yet to go to
For the
space.
first time, sir, from space.
So I have not yet been to space, Fatima. I will if I get assigned.
Thank you, sir.
Yeah.
This point there. Yeah, you are the one. Last one. Yeah. Wait for it. Mike.
Hi, sir. Myself Joshit, and I'm studying in 8th grade. My question for you is, does any of your experience as a fighter pilot actually inspire you for becoming an astronaut now? Did it inspire you in any way?
Of course, because okay, I don't have any bias as a fighter pilot. Okay, I honestly feel that going to space is all about doing the science there. It's ultimately the scientist's domain. But I would not deny that for becoming an astronaut, if there is one profession here on planet Earth which comes very, very close to it, and if I had an option between 5 people and I have very less time to launch someone into space, a fighter pilot who's a test pilot, he'll be the first choice because he's already trained 60 to 70% of the training which is imparted in astronaut training is already imparted to side career which is called the fighter pilot. That doesn't make him more eligible any which ways, but he becomes the preference, so to speak. And we have to understand one thing in astronautics. There are operational aspects of astronautics. Then there is the part in which you go and do the experiments. So these are two different fields altogether. For example, people may very, very casually honor me by saying, oh, he's also a scientist. I'm currently in ISRO, working in ISRO as a scientist grade person, scientist SG. But I'm not a scientist, to be honest. Okay, that's a different field of specialization which requires a different kind of a rigor. I am also completing my MTech from IISc. That also doesn't make me an engineer. An engineer, a scientist, these are specialized fields wherein you need to work from after school or after college. You worked in that thing for decades and you have the perspective and the way, the outlook. So the operational outlook, when I talk about how operations are conducted at very high speeds, that only very few people on this planet can do. And the people who are trained to do that, for example, I don't look down on helicopter or transport pilots, but when it comes to high speed operations, only a fighter pilot is able to or trained to do it. So the operational aspect of taking a spacecraft from here on Earth to the space station, docking, transferring people, undocking and coming back, or going to the moon, these are all operational domains which people who know how to do operations regularly are best suitable to do those. However, when you reach the space station, then performing a specific experiment, let's say in biochemistry, material science, or for example combustion engineering, only a combustion engineer or a bio guy can do it. You can tell me that, okay, you go press these buttons and everything. It's not a simple task performing an experiment and extracting the data or the results with the kind of sanctity. A scientist will do it. I can't do it, to be honest. But when it comes to operations, things start going wrong. I know how to control the situation. So it's a very, very specialized field. Yeah, I hope I have answered your question. Maybe I've stretched a bit.
Good afternoon, sir. Myself, Panaga Biarjun. I'm studying in class 10. My question is that you have tried different fields like mountaineering, scuba diving, and many more. And you have a regret that you haven't tried as such a field. And how did you manage your time for all the achievements which you have done?
What regret you were saying?
I mean, which field you haven't tried, or the thing which you wanted to try but you couldn't do that?
No, I think for now I've overdone myself already. I don't want to try anymore.
Sir, and how did you manage your time?
Yeah. So how did I manage my time? So what I do is I follow a simple formula which I learned in the armed forces. So in the armed forces, they have a saying that if, let's say, this be the border, there's a person who's coming from the opposite side. Okay? So you don't ask him whether you are from the opposite side. You first beat him up and then you ask him, who are you? Are you understanding? And similarly, the same concept you must have seen in the movie Maverick, right? He says, don't think, just do. So you don't think. Most of the times we say no to things because we think a lot, overthink. Oh, should I go for scuba diving now? No, these exams are there. No, should I go for scuba diving course now? No, but that meeting is there. Those people are coming, relatives are coming. You have to decide whether you want to live the life of an average individual
who engages himself into these worldly affairs, or you want to seek glory of a different kind. You have to understand one thing. There are only 24 hours in a day. You have to realize what all are you ready to lose for gaining something else. And you need to realize what is a gain for you. There are people who love a simple life and there's nothing wrong in that. I'm not looking down on those people. But if you are the dreamer kind, then you need to sacrifice on a lot of things to gain on other things. You just need to be clear on what you want in life. Yeah?
Thank you. Then,
my name is Judy and I'm in 5th standard. I wanted to know, how do you manage your stamina while you run?
Manage my stamina, right?
Yeah.
Okay. So, as far as the stamina part is concerned for running, be it stamina during running or be it stamina during an examination of any kind or performance. Basically, you're talking about performance in one specific domain called running here. To begin with, that stamina did not happen like that. So I'm a person who used to, I'm a very, very passionate runner from my early days. I used to, 5,000 people used to run and I used to come second position, okay. So I was a good runner to begin with. And yes, there have been times that my performance has improved in my life because I wasn't eating well, I gained a lot of weight and everything. But I have always ensured that running is one fire within me that I will never allow to extinguish. That is one thing. When you are clear about that aim, there is no way that the thing will come down to the stage where we start discussing about stamina. Yes, when it comes to any kind of physical training related activity or any kind of academic activity also, I have always followed one golden rule: volume of training. So when I was going for the test pilot examination, they have a very tough examination in mathematics, and as pilots you don't read that kind of mathematics regularly. You know, a lot of hi-fi integration and differentiation and linear algebra. All that you need to do to reach a certain level is increase the volume of your training of mathematics. The more you practice, the more you practice. So that's what I've done for anything that I go for. So if I'm going for running event, I will just keep running more and more. And then I'll reach I have built stamina in the process. So it's not that my stamina is quantity X. It's a variable thing and I can build it.
Yeah, there is a small kid there. Let us see what he asks. Yes. Come. What's your name?
Good evening, sir. My name is Rohan. I'm going to 3rd standard.
Yeah, what's your question?
What are the expectations from the younger generation?
Oh, I think.
Your name is Rohan, right? You're the cutest guy who's ever asked me a question, first of all. But you've asked a question which is very, very superior, okay? So my expectations from the younger generation, that's something which I myself wanted to answer, okay? It's good that you've asked me this question. So my expectations from the younger generation is that the younger generation should realize by drawing comparisons with other countries, where India is today and where they are, because of following the simple principle of investing themselves in the field of science. You may not understand all this completely, but others will, okay? So it is important for the current youth to take up sciences as a career. And it is not important to become an astronaut only. All the front row heavyweights who are sitting here, it is on the basis of the machine that they are going to build. I am going to sit in that machine and go. If they won't have built it, where is the astronaut? I can only jump here on Earth and land back. So look at the big picture. contribute, work with an aim to contribute in the field of science. It could be by becoming a scientist, a technician, a doctor is also in the world of science only, okay? So you're supposed to work for the, the society in general. I'm a big science lover, so I'm not asking you to not pick up arts and commerce, and all those who are from arts and commerce here, I'm not looking down on them at all. But it's definitely a difficult field, especially when you reach in your higher grades, you start realizing, what did I do to my life? But trust me, endure, 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 and science will give you back, right? So please do it for your country. Invest your youth and energies in the world of science. Yeah.
That boy, and after that, 2 more questions. Okay? Please, because we have other questions. Yeah, you can.
Hello, sir. My name is Haren, and I'm in 10th grade. So, does the popularity and fame of being selected as an astronaut, is it sometimes very annoying?
Yeah, till now it hasn't been. Although I'll tell you, this there are some last minute changes in this presentation also, which I did on the way to this place. So I'm like, definitely things do get very busy at times, okay? But finally there's nothing annoying about it. So if you were to ask me, I'm a bit greedy when I'm coming to an event like this, because I know I will learn a lot. It's not about the pictures and the showbiz and the claps and everything, but the learning and the knowledge, okay? So if you are a positive person, there's nothing annoying in this world, in fact. If something did not happen for a particular point of time, be rest assured that there's something bigger meant for you. So if you're a very, very positive person, it doesn't matter you wanted to become a doctor, you ended up becoming a nurse. You wanted to become a particular type of doctor or an engineer and you ended up becoming somebody else. You wanted to become a fighter pilot, but you became a helicopter pilot. People who are, right over here, they will be the ones who will be always good with it. So when you reach this stage, what can possibly be annoying? Yeah?
Yes, this boy.
Good afternoon, sir. My name is Sai Samath and I'm studying currently in 9th grade. My question to you would be, what was the psychological motivation that kept you going to achieve your goal, and what should be the psychological motivation one must have to achieve their goals?
Okay, when we are talking about psychology, please understand one thing, that it is very difficult to train, it is very difficult to change one's psychology. The basic psychology cannot really be changed a lot. But we have to understand one thing, how we interact with others is not our psychology, it is our behavior. And with the proper kind of psychological training, at the superficial level, it is possible to change your psychological traits and completely change your behavioral skills. Okay? So one of the things that you will find probably is that once you get to interact with any of the astronauts, you will find that most of them are pretty similar in behavior, irrespective of whether they are from any country. Because astronauts are people who've been sort of trained to represent the whole of humankind or humanity. They don't talk about nationalistic barriers, color, caste, creed, religion. So that's what it's about. So I won't really talk about psychological training as much, because I've already been trained, and what all has happened, it's like too massive to cover over here. But I think you get the point. Yeah?
Last question. Yeah, that girl. Yeah, that's no. Yeah, please ask.
Good afternoon, sir. I am Vaibhavi of grade 10. So I have 2 questions for you. The first one is, how are you mentally and emotionally prepared, as you have to stay away from your friends and family for a long time? And the second question is, what is the first thing you want to do when you set foot on other planets or moon?
What would I do, right?
Yeah, what would you do?
Yeah. Okay. Thank you for asking a nice question. See, I would like to first of all clarify here that I won't really say that I have become a complete astronaut for now. It's a journey that I am currently in and I'm kind of experiencing and I'm on the way. Only probably after I've tasted my first space flight would I really say that I'm an accomplished astronaut. Right now I can say I'm an astronaut designate to begin with. Yes, there are a lot of hardships as far as staying from the family is concerned. And there are a lot of emotional ups and downs that you see during the training period and in the journey as an astronaut. But I would say the psychological training again comes in to help you to tackle those things. And to be honest, I would say that if you won't have been able to tackle those, you will not get selected in the first place. Okay, so the kind of people they select themselves are, one of the biggest parameters for selecting an astronaut is his stress-taking capability, which is tested in so many ways that it's unimaginable to, put it or quantify it that what is the level of stress taking. They check you from all possible angles. So yeah.
Thank you very much. Thank you. Yeah. We have other 3 programs. We are already short of time by 15 minutes. So anyway, see, all of you have in the past 35 to 40 minutes, we have had the interaction or Q&A, and you have all been enlightened about the way in which an astronaut gets selected and what are all the challenges for him or her. And it is not only glamour. Group Captain Angad Pratap has emphasized that, and brilliant questions and equally or more brilliant answers. Thank you, sir, once again for not only answering but for inspiring a generation. On behalf of U R Rao Satellite Center and Jawaharlal Nehru Planetarium, who have organized this Aryabhatta launch Golden Jubilee celebrations, I heartily thank you for coming here and enlightening all the students and children. Thank you very much, sir. Good day. Now, Ms. Sharanya will announce what is next once again. Please.
Satellite Aryabhatta was launched 5 decades back in April 1975. A nostalgic look at the tremendous growth of satellite technology in India in the past 5 decades inspires us to take the country to much greater heights in the domain of space. Aryabhatta was built under the leadership of Professor Ramachandra Rao, known to millions as Professor U R Rao. He is undoubtedly the father of Indian satellite program. Today, many Indian satellites are rendering valuable services to the country, while others like Astrosat have trained their eyes on the heavens. Besides, robotic spacecraft like Chandrayaan, Mars Orbiter mission and Aditya L1 have explored the Moon, Mars and the Sun. They have glaringly revealed India's unique capability to conduct space exploration at a reasonable cost. In 2009, Chandrayaan-1 made the path-breaking discovery of conclusively finding water on the Moon. Chandrayaan-2 is taking crystal clear pictures of the lunar surface as it orbits the Moon. Chandrayaan-3 made the pioneering touchdown in the South Polar region of the Moon. Mars Orbiter mission spacecraft enabled India to become the first country to score 100% success in its very first mission to explore the red planet. And Aditya L1 is performing round-the-clock solar surveillance from a special vantage point 1.5 million kilometers away. Encouraged by these successes, India has set its sight on the more ambitious goals to explore Venus as well as to further explore the Moon and Mars. As it perseveringly endeavors to explore space with passion, the country feels that the sky is not the limit.
Aryabhatta was a small satellite which brought realization in Indians that we too can dream big. The journey had started much earlier when Dr. Gurup Prasad entrusted the task of preparing a thesis on how satellites can be used to Professor U R Rao.
So I wrote a sort of a thesis, took 2 months, and then gave it to him. And he said, I like the thesis, wonderful it is, but one thing I don't like. I said, what is it which you don't like? He said, you haven't said who is going to do it. I said, Vikram, that is your problem, to find somebody who is going to do it. You wanted me to write the thesis, I wrote a thesis for you. And he said, no, you have to accept it.
At Pena, on the outskirts of Bangalore city, Professor U R Rao was shown the skeleton of a few industrial sheds which were just being built for the new Pena Industrial Estate. Immediately, he booked for the first 4 sheds, each with 5,000 square feet area, to start the Indian Scientific Satellite Project, previously known as the Indo-Soviet Satellite Project. By the end of August 1972, we got the sheds.
We assigned him the task to organize the team. We hired a few buildings at Pena, which is a little village a few miles away from Bangalore, and Professor Rao and his team rapidly converted these into the satellite laboratory.
Aryabhatta is a spin-stabilized 360 kg satellite of nearly 1.5 meter diameter, having a multifaceted oblate spheroid shape with 26 faces made up of body-mounted solar panels generating 50 watts power. Altitude is provided by sun aspect sensors, digital sun sensors and a magnetometer. It's a spin-stabilized satellite. It has a tape recorder for recording 40 minutes of telemetry data and batteries. Cosmos chips are used in the system to meet low satellite power. It has a dual redundant telecommand system, dual redundant telemetry system with common telecommand and telemetry antennas. The work went on in an unbelievable pace. To study the physical characteristics of the satellite in actual conditions in space, a structural model of the satellite and a thermal model were built and tested. A half model was tested and qualified with the dummy last stage of the rocket in USSR. An electrically working model was flown on a helicopter over Sriharikota ground station and over the Bears Lake station near Moscow to test the operation of the entire telemetry, telecommand and communication links. An interferometer system for providing the precise orbit of the satellite was built in Sriharikota. 2 months before the launch, the team suddenly felt the need to have a second telemetry ground station for redundancy, in addition to the main station at Sriharikota. Behind the sheds, 2 lavatories meant for women were cleaned up and quickly converted into a full-fledged ground station. 1
0 hour ticks forward. A tense excitement prevails. And off goes Aryabhatta, India's first scientific satellite.
Aryabhatta project continues to be the benchmark.
Moon. This familiar object in the night sky has inspired the imagination of astronomers and ordinary people alike. From time immemorial, humans have marveled at the beauty of the moon, used it to count time and navigate the high seas. In modern times, Moon, the only natural satellite of the Earth, has acquired added importance due to the belief that Moon is the key to our understanding of the evolution of the solar system in general and Earth in particular. Besides, Moon's precious resources and low gravity have further endeared it to humans. India, a major spacefaring nation, has conducted a detailed exploration of the Moon through its Chandrayaan program. The country has sent 2 robotic spacecraft to orbit the Moon and to take a repeated look at its surface. Chandrayaan-1 demonstrated India's ability to reach the surface of the Moon at a place and time of its choice. And with it, India became the 4th country to reach the surface of the Moon in November 2008. Besides, Chandrayaan-1's conclusive discovery of water on the Moon in 2009 was praised as a path-breaking discovery. The follow-on mission, Chandrayaan-2, had an orbiter, a lander called Vikram, and a rover named Pragyan. In the past 4 years, the orbiter has repeatedly observed the lunar surface and even today is working satisfactorily. Now, 3,900 kilograms Chandrayaan-3 spacecraft is being sent to the Moon with the objective of making yet another focused attempt to slowly land on the lunar surface and to explore it with the help of a rover. Following the spacecraft launched by India's most capable rocket LVM-3, the Chandrayaan-3 lander carrying a rover within it will be carried into an orbit around the Moon by the propulsion module. A little later, the lander will separate from that module and will attempt to make a soft landing in the south polar region of the Moon. This region is of intense interest as it has many permanently shadowed craters which could contain water ice and precious minerals. Chandrayaan-3 lander has 4 scientific instruments or payloads, of which one will study the moonquakes, while the other one studies as to how the surface of the Moon allows heat to flow through it. The third one will study the plasma environment near the Moon's surface. And the 4th instrument will enable scientists to measure the distance between the Earth and Moon very accurately. The two instruments on the rover help us study the composition of the moon's surface using X-rays and laser respectively. While the lander and rover will be in direct contact with each other. The propulsion module circling the moon will observe the light coming from Earth, the only planet which we know which is definitely teeming with life. This observation will help in understanding the nature of distant planets circling stars other than the Sun. As Chandrayaan-3 undergoes important tests and gears up for launch, thousands of ISRO scientists, including those who will launch it, control it and receive the precious scientific information from it using giant dish antennas, are readying themselves for the challenging tasks ahead. In the past, their dedication and skill have enabled India to earn praise from across the world and made it proud. Let us wish them well in this great endeavor called Chandrayaan-3.
गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal. P1 tracking.
R2 tracking.
P2 tracking. Stage performance normal. P4 tracking. L1 turn stage ignited.
Plus 2 minutes.
L1 turn stage performance normal. Stages are separated. Closed loop guidance initiated.
The Aditya L1 mission carries a suite of 7 scientific payloads to carry out systematic study of the Sun. The Visible Emission Line Coronagraph (VELC) studies the solar corona and dynamics of coronal mass ejections. The Solar Ultraviolet Imaging Telescope (SUIT) payload images the solar disk in near ultraviolet and also measures the solar irradiance variations. The Aditya Solar Wind Particle Experiment, Aspects and Plasma Analyzer Package for Aditya, PAPA payloads study the solar wind and energetic ions as well as their energy distribution. The Solar Low Energy X-ray Spectrometer, SOLEXIS, and the High Energy L1 Orbiting X-ray Spectrometer, Helios, study the X-ray flares from Sun over a wide energy range. The magnetometer payload is intended to measure the interplanetary magnetic field at the L1 point. The science payloads of Aditya L1 are indigenously developed by different laboratories in the country. VELC is developed at the Indian Institute of Astrophysics, Bengaluru, Suite Instrument at Inter-University Centre for Astronomy and Astrophysics, Pune. Aspects Instrument at Physical Research Laboratory, Ahmedabad. PAPA payload at Space Physics Laboratory, Vikram Sarabhai Space Center, Thiruvananthapuram. Solexus and Helios payloads at U R Rao Satellite Center, Bengaluru, and the magnetometer payload at the Laboratory for Electro-Optic Systems, URSC.
ಚಂದ್ರಯಾನ 3 ಚಂದ್ರಯಾನ 2ರ ಮುಂದುವರೆದ ಯೋಜನೆ. ಚಂದ್ರಯಾನ 3ರ ವಿನ್ಯಾಸವನ್ನು ಚಂದ್ರಯಾನ 2ರ ಸಾಧಕ ಬಾಧಕಗಳನ್ನಾಧರಿಸಿ ರಚಿಸಲಾಗಿದೆ. ಚಂದ್ರಯಾನ 3 ಅಂತರಿಕ್ಷ ನೌಕೆಯಲ್ಲಿ 2 ಘಟಕಗಳಿವೆ. ಇಂಧನ ಘಟಕ ಮತ್ತು ತನ್ನ ಮಡಿಲಲ್ಲಿ ರೋವರ್ ಅನ್ನು ಹೊತ್ತ ಲ್ಯಾಂಡರ್ ಘಟಕ. ಚಂದ್ರನ ಮೇಲೆ ಹಿತವಾಗಿ ಹಾಗೂ ಕ್ಷೇಮವಾಗಿ ಇಳಿಯಲು ಬೇಕಾದ ದೃಢತೆ, ವಿವಿಧ ಸನ್ನಿವೇಶಗಳಲ್ಲಿ ಸ್ವಯಂ ನಿರ್ಧಾರ ತೆಗೆದುಕೊಳ್ಳಬಲ್ಲ ಕೃತಕ ಬುದ್ಧಿಮತ್ತೆಯನ್ನು ಲ್ಯಾಂಡರ್ ಹೊಂದಿದೆ. ವೈಪರೀತ್ಯ ಸನ್ನಿವೇಶಗಳಲ್ಲೂ ಸಕ್ಷಮವಾಗಿ ಕಾರ್ಯನಿರ್ವಹಣೆಯನ್ನು ದೃಢೀಕರಿಸಲು ವಿಸ್ತೃತವಾದ ವಾತಾವರಣ ಅನುಕರಣಾ ಪರೀಕ್ಷೆಗಳನ್ನು ನಡೆಸಲಾಗಿದೆ. ಚಂದ್ರಯಾನ 3ರ ಇಂಧನ ಘಟಕವು ಲ್ಯಾಂಡರ್ ಅನ್ನು 100 ಕಿಲೋಮೀಟರ್ ಚಂದ್ರನ ಹತ್ತಿರದ ಕಕ್ಷೆಗೆ ಕೊಂಡೊಯ್ಯುವ ಪರಿಭ್ರಾಮಕವಾಗಿ ಕಾರ್ಯನಿರ್ವಹಿಸುತ್ತದೆ.
ಲ್ಯಾಂಡರ್ ಘಟಕದಲ್ಲಿ 4 ಪ್ರಮುಖ ಕಾರ್ಯೋದ್ದೇಶಿತ ಉಪಕರಣಗಳಿವೆ. ಅವೆಂದರೆ ಚಾಸ್ಟೆ, ಚಂದ್ರ ಸರ್ಫೇಸ್ ಥರ್ಮೋಫಿಸಿಕಲ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್; ರಂಭ, ರೇಡಿಯೋ ಅನಾಟಮಿ ಆಫ್ ಮೂನ್ ಬೌಂಡ್ ಹೈಪರ್ ಸೆನ್ಸಿಟಿವ್ ಐನೋಸ್ಫಿಯರ್ ಅಂಡ್ ಅಟ್ಮಾಸ್ಫಿಯರ್; ಇಲ್ಸಾ, ಇನ್ಸ್ಟ್ರುಮೆಂಟ್ ಫಾರ್ ಲೂನಾರ್ ಸೀಸ್ಮಿಕ್ ಆಕ್ಟಿವಿಟಿ; LRA, ಲೇಸರ್ ರೇಡಿಯೋ ರಿಫ್ಲೆಕ್ಟರ್ ಅರೆ. ಚಾಸ್ಟೆ ಉಪಕರಣವು ಲ್ಯಾಂಡರ್ ಇಳಿದ ಸ್ಥಳದ ಮೇಲ್ಮೈ ತಾಪಮಾನ ವೈಪರೀತ್ಯಗಳನ್ನು ಅಳೆಯುತ್ತದೆ. ರಂಭ ಮೇಲ್ಮೈ ವಾತಾವರಣದಲ್ಲಿನ ಪ್ಲಾಸ್ಮಾ ಸಾಂದ್ರತೆಯಲ್ಲಾಗುವ ವ್ಯತ್ಯಯಗಳ ಮಾಹಿತಿ ನೀಡುತ್ತದೆ. ಇಲ್ಸಾ ಚಂದ್ರನ ನೆಲದಲ್ಲಿ ಸಂಭವಿಸಬಹುದಾದ ಕಂಪನಗಳ ಮಾಪಕ. LRA ಲೇಸರ್ ಆಧಾರಿತ ಅನ್ವೇಷಣೆಯ ಮೂಲಕ ಲ್ಯಾಂಡರ್ ಇಳಿಯುವ ಸ್ಥಳದ ಸೂಕ್ತತೆಯ ಮಾಹಿತಿಯನ್ನು ನೀಡುವ ಕಾರ್ಯನಿರ್ವಹಿಸುತ್ತದೆ. ಚಂದ್ರಬಂಡಿ ರೋವರ್ನಲ್ಲೂ 2 ಕಾರ್ಯನಿರ್ವಾಹಕ ಉಪಕರಣಗಳಿವೆ. ಅವೆಂದರೆ ಲಿಬ್ಸ್, ಲೇಸರ್ ಇಂಡ್ಯೂಸ್ಡ್ ಬ್ರೇಕ್ಡೌನ್ ಸ್ಪೆಕ್ಟ್ರೋಮೀಟರ್, ಮತ್ತು APXS, ಅಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ ಎಕ್ಸ್ರೇ ಸ್ಪೆಕ್ಟ್ರೋಮೀಟರ್. ಲಿಬ್ಸ್ ಚಂದ್ರನ ಮೇಲ್ಮೈಯ ರಾಸಾಯನಿಕ ಸಂಯೋಜನೆ ಹಾಗೂ ಖನಿಜಗಳ ಮಾಹಿತಿಯನ್ನು ನೀಡಿದರೆ, APXS ಚಂದ್ರನ ಮಣ್ಣು ಹಾಗೂ ಶಿಲೆಗಳಲ್ಲಿರುವ ಮೂಲ ವಸ್ತುಗಳನ್ನು ಪತ್ತೆ ಹಚ್ಚುತ್ತದೆ. ಹಿತವಾಗಿ ಹಾಗೂ ಕ್ಷೇಮವಾಗಿ ಚಂದ್ರನ ಮೇಲಿಳಿಯಲು ಲ್ಯಾಂಡರಿನ ಸ್ಥಾನ ಮತ್ತು ವೇಗದ ಕ್ಷಣ ಕ್ಷಣದ ನಿಖರವಾದ ಮಾಹಿತಿ ಅವಶ್ಯಕ.
ಉಡಾವಣಾ ವಾಹನದಿಂದ ಬೇರ್ಪಟ್ಟ ನಂತರ ಲ್ಯಾಂಡರ್ ಮಾಡ್ಯೂಲ್ನಿಂದ ಕಳಚಿಕೊಳ್ಳುವವರೆಗೆ ಅದನ್ನು ಒಯ್ಯುವುದು ಪ್ರೊಪಲ್ಷನ್ ಮಾಡ್ಯೂಲ್ನ ಮುಖ್ಯ ಕಾರ್ಯವಾಗಿದೆ. ಆರು ಚಕ್ರಗಳುಳ್ಳ ರೋವರ್ ಅನ್ನು ಲ್ಯಾಂಡರ್ ಒಳಗೆ ಅಳವಡಿಸಲಾಗಿದೆ. ಚಂದ್ರನ ಮೇಲ್ಮೈ ಮೇಲೆ ಲ್ಯಾಂಡರ್ ಇಳಿದ ನಂತರ ರೋವರ್ ಲ್ಯಾಂಡರ್ನಿಂದ ಹೊರಬರುತ್ತದೆ. ರೋವರ್ನ ಸೋಲಾರ್ ಪ್ಯಾನೆಲ್ ತೆರೆಯುವಿಕೆ ಮತ್ತು ಸೂರ್ಯ ಕಿರಣಗಳ ಪ್ರಕಾಶನ ಪರೀಕ್ಷೆ, EMI, EMC ಪರೀಕ್ಷೆ, ಕಂಪನ ಪರೀಕ್ಷೆ, ಶೀತೋಷ್ಣ ಪರೀಕ್ಷೆಗಳು, ದ್ರವ್ಯರಾಶಿ ಗುಣಗಳ ಮಾಪನಗಳನ್ನು ನಡೆಸಲಾಯಿತು. ICT ಮಾಡ್ಯೂಲ್ ಎಂಬ ಪರೀಕ್ಷಾ ಮಾಡ್ಯೂಲ್ ತಯಾರಿಸಿ ಅದನ್ನು ಚಿತ್ರದುರ್ಗದಲ್ಲಿ ಹೆಲಿಕಾಪ್ಟರ್ ಸಹಾಯದಿಂದ ICT ಪರೀಕ್ಷೆಗಳನ್ನು ನಡೆಸಲಾಯಿತು. ಇದೇ ಮೊದಲ ಬಾರಿಗೆ ವಿಶಿಷ್ಟ ಪರೀಕ್ಷಾ ವಿನ್ಯಾಸದಲ್ಲಿ ಇಂಜಿನ್ಗಳನ್ನು ಇರಿಸಿ ವೇಗ ನಿಯಂತ್ರಣವನ್ನು ಸಾಧಿಸುವ IHT ಪರೀಕ್ಷೆಯ ಮೂಲಕ ಎಲ್ಲ ಅಗತ್ಯ ಪರೀಕ್ಷೆಗಳನ್ನು ಕೈಗೊಳ್ಳಲು ಅವಕಾಶವಾಗುವಂತೆ ಸಮಗ್ರವಾದ ಮಾಡ್ಯೂಲ್ ಅನ್ನು ತಯಾರಿಸಲಾಯಿತು. 6 ಪೂರ್ವ ಅನುಕರಣಾ ಪರೀಕ್ಷೆಗಳು, 8 ಸ್ಥಾಯಿ ಪರೀಕ್ಷೆಗಳು ಮತ್ತು 6 ಡೈನಮಿಕ್ ಪರೀಕ್ಷೆಗಳನ್ನು ಒಳಗೊಂಡಂತೆ ಒಟ್ಟು 20 ಪರೀಕ್ಷೆಗಳನ್ನು ಯಶಸ್ವಿಯಾಗಿ ನಡೆಸಲಾಗಿದೆ. ಚಂದ್ರನ ಮೇಲ್ಮೈ ಸ್ಪರ್ಶಿಸುವ ಸಮಯದಲ್ಲಿ ಲ್ಯಾಂಡರ್ ಕಾಲುಗಳ ಶಕ್ತಿ ಹೀರಿಕೊಳ್ಳುವ ಸಾಮರ್ಥ್ಯ ಪರೀಕ್ಷಿಸಲು ಹಾಗೂ ಶಕ್ತಿ ಮತ್ತು ಸ್ಥಿರತೆಯ ಅಂಶಗಳನ್ನು ಮೌಲ್ಯಮಾಪನ ಮಾಡಲು ಲ್ಯಾಂಡರ್ ಕಾಲುಗಳನ್ನು ಮೇಲಿನಿಂದ ಬೀಳಿಸುವ ಪರೀಕ್ಷೆಗಳನ್ನು ನಡೆಸಲಾಯಿತು. ಸಿಮ್ಯುಲೇಟರ್ ಮಾದರಿಯ ಮಟ್ಟದಲ್ಲಿ ಒಟ್ಟು 15 ಮೇಲಿನಿಂದ ಬೀಳಿಸುವ ಪರೀಕ್ಷೆಗಳು ಮತ್ತು ಅರ್ಹತಾ ಮಾದರಿಯ ಸಂರಚನೆಯ ಮಟ್ಟದಲ್ಲಿ 2 ಮೇಲಿನಿಂದ ಬೀಳಿಸುವ ಪರೀಕ್ಷೆಗಳನ್ನು ಯಶಸ್ವಿಯಾಗಿ ನಡೆಸಲಾಯಿತು. ದ್ರವ್ಯರಾಶಿ ಗುಣಗಳ ಮಾಪನ, ಶೀತೋಷ್ಣ ಪರೀಕ್ಷೆಗಳು, ಸೋಲಾರ್ ಪ್ಯಾನೆಲ್ ಮತ್ತು ಅದರ ಸೂರ್ಯ ಕಿರಣಗಳ ಪ್ರಕಾಶನ ಪರೀಕ್ಷೆ, EMI, EMC ಪರೀಕ್ಷೆಗಳನ್ನು ಐಸೈಟ್ನಲ್ಲಿರುವ ಕ್ಯಾಟಫ್ನಲ್ಲಿ ಪರೀಕ್ಷೆಗಳನ್ನು ನಡೆಸಲಾಯಿತು. ತದನಂತರ ಸೆಕೆಂಡರಿ ರೋವರ್ ರ್ಯಾಂಪ್, ಪ್ರೈಮರಿ ರೋವರ್ ರ್ಯಾಂಪ್, ರೋವರ್ನ ಲ್ಯಾಂಡರ್ನಿಂದ ಹೊರಬರುವ ಕಾರ್ಯಗಳನ್ನು ಪರೀಕ್ಷಿಸಲಾಯಿತು. ನಂತರ ಪೇಲೋಡುಗಳಾದ ಇನ್ಸಾ, ರಂಭ ಮತ್ತು ಚಾಷ್ಟೆಗಳ ತೆರೆದುಕೊಳ್ಳುವಿಕೆಗಳನ್ನು ಖಚಿತಪಡಿಸಿಕೊಂಡು ಲ್ಯಾಂಡರಿನ ಮುಂದಿನ ಚಟುವಟಿಕೆಗಳಿಗೆ ಅನುವು ಮಾಡಿಕೊಡಲಾಯಿತು. ರಾಷ್ಟ್ರೀಯ ತಜ್ಞರ ಸಮಿತಿಯ ಸಲಹೆಗಳು ಹಾಗೂ ಇಡೀ ಇಸ್ರೋ ತಂಡದ ಅವಿರತ ಪರಿಶ್ರಮದ ಫಲವಾಗಿ ಚಂದ್ರನ ಮೇಲೆ ತ್ರಿವರ್ಣ ಧ್ವಜ ಹಾರಿಸುವಲ್ಲಿ ಹಾಗೂ ರಾಷ್ಟ್ರ ಲಾಂಛನ ಮೂಡಿಸುವಲ್ಲಿ ಚಂದ್ರಯಾನ 3 ಯಶಸ್ವಿಯಾಯಿತು.
Mission Operation Complex at ISRO's Telemetry, Tracking and Command Network, ISTRAC, situated in Namma, Bengaluru, Karnataka.
हाँ, अब हम देख सकते हैं रफ ब्रेकिंग फेज की शुरुआत हो चुकी है।
Visualization of the lander module moving towards the moon's surface. We are nearing the final phase of the power descent, which is going to be the vertical descent phase or the local navigation phase.
जी हाँ, अब हम फाइन ब्रेकिंग फेज के एकदम करीब आ चुके हैं। हाँ, आप तालियों के गड़गड़ाहट से सुन सकते हैं कि
Sir, we have achieved soft landing on the moon. India is on the moon.